The guys.
Live from across the plane. Back for season 4. Your hosts, Bob, John, and Jaren. Enjoy the show. By the way, it is flat. Now, the Globebusters.
And welcome everybody to Globebusters, Flat Earth, Why Do We Play By Their Rules? I am your host, Bob, Xanadude60, and we have another great show for you today. We're going to cover some new stuff, but we also have some unfinished business, I believe, with the Eclipse models. We have some new information, some new evidence, some new thought processes for people to consider, and have a great panel to present it today. But before we get to that, I am going to go ahead and introduce my two co-hosts, and today we'll start with John. John the Morgile. How are you doing today, John?
I'm doing all right, man. Glad to be with you guys. Beautiful day, and I really love the topic of Eclipse, so I'm really just going to maybe soak a lot of this in. I made a video recently about eclipses. If y'all haven't seen it, watch that after the show, and hopefully we'll get some work done here because, eclipses is a very, very awesome topic. I know we're going to touch on that, and why do we play by their rules is a great topic, so looking forward to it.
Outstanding. Yeah, I know. I have only gotten the chance to get through about 20 minutes of your video. It has been a chaotic week for me. As you guys know, I don't know if you heard last week, but at the end of the show, Cammie made a comment about how I wasn't feeling too well, and I was kind of feeling kind of cruddy. And for the next 4 days, I had one of the worst flus or something ever. It was kind of a reiteration of what happened in Hawaii, but that only happened for like a half a day, and then I was okay. But this time it came back in force and just really kicked the crud out of me. So I didn't get a whole lot done. And then, of course, it was a week full of emergencies, on top of the fact that I had just been on vacation for 2 weeks. So what a chaos week. I hope I don't have another one of those for a while, I'll tell you. So also we have Jaren from Jarenism. Hey, Jaren, how you doing this week and today?
Fantastic, Bob. Glad you're feeling better.
Yeah, I'm feeling a whole lot better, that's for sure. And I have to say that I listened to your the infamous 10 list. I didn't get through that all the way either, but I have to tell you, there were some points in there I was cringing and I was kind of yelling at the computer because those guys are really kind of upsetting me. Even though it was a fairly civil discussion, it just seemed like they were really missing a lot of the point, and we'll talk about that a little bit today. But wow, you have the patience of a saint. You know that?
Well, you learn as you go, and yeah, I think we're getting a little better each time and learning from the mistakes. So I think that it's all good.
Yep, absolutely. And David was right in there with you, and he was doing a great job also. So okay, so we have another repeat guest. We actually have a few repeat guests, and we have a brand new guest with us today for the first time. You guys may know him. His name is Mike Helmick, and Mike has done some fantastic work on debunking NASA, showing how their CGI works. Of course, he's worked with Archer Sage also as well in debunking a lot of their imagery. He's just really brought a whole lot of valuable information to us, and lately he's been very deeply kind of involved in the Eclipse model, and trying to understand it, and also trying to debunk it as well. So he's got a lot of great stuff for us today. So how are you doing today, Mike? Oops, I think you're still muted, Mike.
Yes, Mike's finding the unmute button as we speak. I'm doing awesome, Bob. I'm glad to be with you guys.
Awesome. Glad to hear it. And also, we have Chris Van Maitre with us today. And as you know, Chris is my neighbor here in Denver. He's going to be doing the balloon launch with me on August 21st, where we will be launching our balloon from Nebraska. We have some details on that coming up. And Chris and I spent the day yesterday kind of going over everything that we're going to be needing and just trying to put together the final details for all the stuff we're going to need for this balloon launch and the eclipse. And other than that, Chris has done some fantastic work. He does some great experiments optically. He does a lot of sun photography and very practical experience. Of course, Chris is also a surveyor, professional surveyor for a long time, I think at least 30 years, something like that. And he is also a pilot. So welcome, Chris. How are you doing today?
Really good. Thank you very much for you guys having me on the show. I feel honored to be on with a panel that's so well-researched and intelligent.
Awesome. Well, we appreciate that too, Chris. And last but not least, we have Antonio Subrats with us, a man who needs no introduction. He has also come up with some new information this week that he's going to be throwing at us, and also kind of entering the roundtable discussion about this eclipse and all the other stuff that we're going to be talking about today. So, Antonio, what'd it be like?
Hello. All is good, apart from Chris just said that he's in a panel with well-researched and intelligent people, so I don't know what the hell I'm doing.
Well, you know,
Flattery gets you everywhere.
Yeah, right. That's awesome.
Yeah, I'm looking forward to the show. This has got to be really difficult for Globies to hear an actual surveyor talking, you know, not just somebody talking about a friend who is a surveyor, you know, an actual surveyor.
Right.
It's cool. It's going to be very good.
Yeah, Chris definitely brings a lot to the table, and we are very happy to hear from him for sure. So anyway, okay, so we have a lot to talk about today, but before we do that, we have our first sponsored message, and so we are going to be playing a message from our sponsor, and we will be back right after a word from our sponsor. So we'll talk to you in just a bit.
T-minus 15 seconds. Guidance is internal.
Plasma's hot at nitrify.
11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engines are running. Liftoff. We have liftoff.
No, cut. Hey, let's wait until we get into orbit before the ball comes down. Thanks.
Not going anywhere for a while?
Right away, people. Back to 1.
Grab a Snickers.
Mission Mars, Scene Apple. Take 2. Marker.
All right, and we are back from our commercial. That was awesome. Again, that little commercial was made by our buddy friend of Yahweh, Andrew, and once again, I saw that and absolutely cracked up. So thank you very much for that, Andrew. Another great comedic relief piece, and we appreciate it. So, all right, so let's go ahead and talk about a couple of things. Yeah, Darren, okay, I'm glad you figured out we were live, because I was sitting there watching the live feed going, oh no, how can we not be live? That's great. So let me bring up my notes here. And so I guess, Jaron, what I want to do is talk about your top 10 podcast that you did a little bit. And if you could tell us a little bit about that, you know, and what you guys talked about, and also that it's on your channel. Just give us a little bit of overview, and then I'll make some comments on it.
Sure, yeah. It's the same two guys. One guy works for NASA, one guy works for SpaceX, and we actually had a kind of impromptu debate that we're not allowed to mirror on our channels. So to find that, you have to go and look for it. And that was a debate that we had recently. It was they cut it into 2 segments, and I'll give Bob the link so he can put it in the show notes. And so after that show, they had said, the 2 guys that were guests on the podcast, just like we were, had said they also had their own podcast called the Twisted 10. And the Twisted 10 is a unique top 10 list that they do, and it's also one of the top 100 podcasts on iTunes. And they had said that what happens is they have guest hosts who come in and present a top 10 list, and they kind of comment on it. And they asked us if we would like to do it. So David and I said yes. And I think they thought we were going to do something flat Earth related. But I thought it was better, or kind of David and I both came to that conclusion, that it might be cool to do something like the top 10 things that we think science should show or prove. This way, we are kind of putting a little, little nugget in these people's heads who believe in that stuff, and that they would see that there is questions to some of the stuff that science reports. And so from there, we just showed up and did the top 10 list. It was on a time constraint because I had Raw at 6 going live, and we started about 4:30. So we only had about an hour and a half till I had to book. But I thought it went pretty well.
Yeah, I think so too. There were a couple things in there that, I was getting a little bit frustrated with when you were talking about, of course, the first thing I believe your number 10 was to put a camera on the moon, and they all seemed to agree with that. Of course, the rebuttal was, well, how is anybody going to know whether or not that's fake or not? And I just thought that's ridiculous. How could you ask that question? But I guess I got to back off and be a little bit more tolerant, because it seems obvious that if there are certain storm fronts going over, or eclipses, or all kinds of activities that would be happening real time on Earth that people are actually experiencing, that you'd be able to see on this moon cam. It just seemed to me that it was kind of a no-brainer. And it also told me that clearly they had never really watched what was on the ISS, right? Because the ISS is so far from reality and what we experience down here. It's ridiculous.
And you go to my videos, that all the videos I've said about no 24/7 ISS feed, it's just filled with people commenting that I just went there. There's a 24/7 feed. It's been there for years. This guy's lying to you. So people still think that there is a 24/7 live feed from space, and they don't understand how, because we can see it from the ground, doesn't mean that it's the same craft that you see on TV. They've never, like we said, walked over during an interview like we thought they were going to do, right? When they did that 4K interview, we thought they would walk over and actually show the Earth, which they never did. And so, yeah, I think that they kind of got that one, but it's something I keep pushing for. A lot of people do tell me, well, if you keep pushing for that, they'll just fake it. And my answer to them is always, there must be a problem with faking it, or else they already would. So same thing with the ISS footage. If they could just fake 24/7 footage, then it would have already been being done. So the fact that it's not being done tells me that there is something about faking it that would be tough, or they're afraid they would get found out. So that's why I keep pushing for that one. To me, you have to have a craft 17,500 miles per hour to fake that footage, or to show that footage. And if you don't have a craft that goes that fast, well, you just need to create a unique kind of feed that cuts out every 30 minutes or so. And this way you never have to maintain that speed, and you never have to reach that speed. But that's kind of my opinion of that one.
Yeah, I totally agree. And the other thing, of course, that you were talking about is you said, well, it would be great if NASA or SpaceX could actually show us some sort of a demonstration of even dropping a car like off a building and then providing enough thrust to stop it in its tracks and be able to set it down, softly. And the guy's rebuttal was, well, all you have to do is come down here to Florida and watch it yourself. And you said something to the effect of, well, yeah, but you witness it from 3 miles away. And from what I've seen, it always seems to go behind this obstruction of a grove of trees or something. So I have to wonder, it's like, does this guy not understand that, we're not seeing this, or at least not to my knowledge, real time, that it's being seen by the public there live, touching all the way down to the ground, unobstructed. And that is my understanding, that nobody's ever been able to see that, because I've certainly never seen it on anything other than a post-released film.
Yeah, I mean, they've showed it, I guess, hitting the ground a couple times in real time from that kind of far away kind of helicopter view. But yeah, that's what they don't understand. It's the same thing with, Red's Rhetoric, who always says, well, come prove my film's wrong, that I'm taking these films of these rockets going up and coming back. And, again, I always bring up I'm sure people have video of David Copperfield making things disappear, but we're smart enough to understand that things can be an optical illusion. And I should be doing a video on it soon, that I have some footage of I think it's the CRS-11 coming back. And I mean, this thing it's like transparent. It really doesn't look like, and again, if I was there watching it, it's not going to look any clearer to me than it does watching someone else's camera feed, because they're zoomed in, over the course of 3 miles or more. And so we're getting to see it zoomed in. If I went there, well, I think what they want me to feel is they want me to feel this sonic boom. And even that's another interesting thing, that when they mention that, And they said, well, you can't fake a sonic boom. And I said, a plane can't fly over your head and create a sonic boom. And they said, why would you do that if you can just land the rocket?
You could just set off an explosive and create a sonic boom.
Right. They just kind of go in this circular argument that doesn't really ever pan out. It's like they could easily fake a sonic boom. A plane could be flying 70,000 feet high and break the sound barrier, and nobody would see the plane, and they would hear the sonic boom. So, I mean, to me, it just is, I guess, and this is the hardest thing, is what I would consider proof, or what I would consider, something that would allow me to call something else a fact, is simply doesn't exist in the space world, in the idea of planets and in the idea of the ISS and in these moon landings. None of them contain the elements of truth that I think need to be there. And as far as, talking about dropping, I mean, I think it's 50,000 pounds when that rocket lands. It could be a little less, maybe 40,000, but that's 10 cars. So if you put 10 Honda Accords, stacked them on top of each other and dropped them off the top of a building, and that's not even, they drop them from 50 miles. I mean, they drop their rocket, it comes back from 50 miles high. But if we just drop those 10 cars from the top of a building, and then imagine how much force would have to be thrown out the bottom of that to have it not crash, that it would have to just slow down, and it basically hovers right before it lands. And when you really look at it, it's got that one little flame coming out the bottom. To me, it's absolutely impossible that you would be able to stop that thing. And if you were able to, you'd blow a hole into the ground.
Yeah, I agree. And also, you mentioned that, they've shown it from some helicopter footage, but, all I can say to that is be leery of helicopter footage, because we all are aware of the Fox News helicopter footage on 9/11, right? Which is exactly where they were, kind of coordinating this entire CGI event, or whatever the heck they were doing on 9/11. But it seemed to definitely be involving computer-generated images for sure, and it all seemed to be coordinated from that Fox News helicopter. And they had a few mistakes with it, and one of the biggest mistakes that came out of that is because the helicopter drifted slightly. They kind of went out of their CGI frame, and the nose of the airliner that crashed through the World Trade Center came out the other side fully intact, and no distortion whatsoever. It's like, whoopsie. So I wouldn't exactly take helicopter images as the real deal.
I just think people need to think about what's going on there too. Is that the rocket is taking off, and then we've seen it goes up, and then it gets towards horizontal, starts heading off into the distance, and it's being powered by the 9 Merlin engines, so it's flying fast and far. And then the second stage releases the first stage rocket to come back, and it does a flip in the sky, and then just starts coming back. But it's not being powered. It doesn't have rockets bursting out the back. So how does it get all the way back? Because it lands just a few miles away from where it took off. So how does it come back? And when they show the video of it, it's basically like at a 45-degree angle, just flying through the air at a 45-degree angle. And then they do an entry burn, they call it, which is when it comes back through the atmosphere. And then it just comes down and lands and hovers right before it lands. It's just the fact that people believe that stuff to me is upsetting.
Yeah, it is. And
it looks like total fakery to me as well.
Yeah, and I will never forget Charles Flatter's mass comments on that, as to how that it was landing at that arc all along. Which,
oh God,
it was just unbelievable. But I listen to Charles, and he frustrates me so much because the guy's a smart guy, but like I said, his job is to debunk things, and therefore even if something of utter common sense hit him in the face, if it was counter to the heliocentric model, he could never acknowledge it, and that's unfortunate. So anyway,
it's because the last time I talked to him was talking about this, and the thing that took me over the edge is when I asked him, well, this rocket coming back and landing backwards is against everything I've ever seen in my life. Don't you agree? And he said, no, it matches everything I've ever seen. Like, the rocket landing backwards matches things you've seen in your life. He's like, yeah. I'm like, all right, that's enough for me. That's just simply not true. I mean, it just doesn't match anything that we know to happen ever.
Yeah, nothing out of the ordinary here, nothing to see here, folks. So anyway,
nope.
And then also real quick, we'll touch on the other video that you released this week. And when I first saw this, Jared, I was thinking, man, I'm glad you put this forward as just a thought experiment, because obviously it would be impossible to have any type of stick or anything like that of that length. But what I found more preposterous was the explanation. They were talking about, sound vibrations, going through it, and it's like, what in the world does sound vibration have to do at all with this? But also the objection I did have to it is, I thought, well, Jaron, you're comparing electromagnetic propagation to something that's solid and there. So you've seen those. We've all seen those little click-clack type puzzles where you have a row of steel balls and they're all on their own little pendulum mechanism, and you pull the end one back and you let it go, and it immediately transfers all that energy through all the balls and pops off the end one, right? So that's something that would be more of a mechanical transfer of energy. But so I kind of got what you were saying on one hand, but I thought it was also comparing apples to oranges, because you were trying to compare something that was solid to an electromagnetic wave. But what I found most comical was the answers that you got back on, what was it, quorum or whatever. I couldn't even believe that people went there with that, like it was even a thing.
Yeah. Well, I mean, the funny thing is, I'm not very good, I guess, at being, making joke videos. I made another one time that nobody liked either, the rendering one. But in this particular video, it's funny because what I'm talking about, I don't believe any of. I don't believe that the sun could possibly be 93 million miles. I don't think that Venus is possibly 25 million miles. So I don't believe that Polaris is, 433 light years away. So it's kind of a joke in the way that it is a thought experiment. But when you take the idea of, those balls transferring energy, like you said, or if we were to take a piece of tungsten and you were to send it to, let's say Venus at 25 million miles, that whether or not that's a transfer of energy or you think it's, transferring things, apples to oranges, regardless, there is energy or something moving faster than the speed of light. And the point of the video was clearly things can move faster than the speed of light. That I don't think that they're necessarily that you can move faster than the speed of light. But what I'm saying is that there's thought experiments that you can do that disprove it right away. And then when you really look at their model, which they've had to do with these light years and thinking all that, to me, that's just all crazy. I mean, I personally believe that the sky is very low, that the sun and stars are very close. And as such, there's no such thing as light years. There's no looking back in time. And part of that is, and I think I told this to David Weiss just as a joke, but at 186,000 miles per second, which is the speed of light, is I told him maybe that number is the circumference of the world. I mean, 186,000, if it's miles per second, just makes sense to me. And then I even was looking at it, what would that be if it was a circumference of a circle? That would put your diameter at 60,000. And I just kind of was saying, maybe they know that nothing from outside of the world can happen to somebody inside. And therefore, that's where they get the speed of light from. But as far as the reason I made the video is the idea of it being a speed limit, it doesn't make sense if you're going to talk about things like the sun or stars, the way that they rotate in the sky. None of that stuff would make any sense if we believe in the speed of light. That it takes a certain amount of time to get here, but for some reason the light stays where it's supposed to be in the sky. It doesn't look like a wavy line all through the sky. So that's what I was trying to get at. And then when you really and I got a lot of people, they answered the same as you, Bob, saying it's impossible to have a stick of such type. Well, yeah, of course it is. Just like it's impossible to have light come from 93 million miles away and light up your world and heat everything around you. These are the kind of things I was trying to point out, is that if we can imagine their world where there is this 8-minute period of time that with the sun blew up, and they also say gravity travels at 8 minutes from the sun. So it means if the sun just disappeared out of nowhere, they say it would take 8 minutes for us to see the sun disappear and for the Earth to get out of its orbit and just start flying off into space. And to me, that's crazy, because you can just take a thought experiment of a tungsten pole going between here and the sun. And if somebody on both ends started pulling their end of the pole, it would take 8 minutes until each other knew that the pole was being pulled. And that to me disproves it right there. I mean, what happens to the pole? How did it gain an extra bunch of feet? And people say, oh, but it's not, there's no such
would have traveled back in time, actually.
Correct. There you go. And that's exactly it. That's the way that they explain it. And these are the facts that we've accepted and that have built the entire universe around us, are around the idea that things like I just described are possible and it would go back in time. Then you start having the causality problem, which is things start happening before they're caused. The results of action start happening before it's just, it alone should disprove the 93 million mile sun.
Right.
Well, if you get a 93 million mile tungsten stick, I want a 7-mile ruler made of at least something like titanium.
Nope. That's impossible.
Yeah. It's not going to be made out of tungsten. It's going to be made out of unobtainium. That's obvious.
Which was discovered by Buzz Aldrin on the moon,
Yeah, exactly. So, all right. So,
isn't that interesting, though, real quick, though, that according to Lions, gravity is just as fast as light? Because I always was taught that light was the speed limit of the universe. Nothing travels close to or approaches the speed of light, except for, of course, theoretical premise of gravity, which is just very convenient, isn't it?
Well, actually, a lot of physicists have said that gravity has no speed limit. It would be instantaneous. And in some examples, I could see how that would be true, assuming I believe that gravity was real in the first place. But let's just say that their argument was logical for it. So instead of gravity being at the speed of light, it would have been instantaneous. But then that goes into a whole nother realm of physics that we're really not going to focus on today.
Right, but it still opens up the same sort of can of worms that Jaron's talking about with the physical stick. You've got the same sort of thing with a non-physical theory of gravity keeping the Earth in orbit, hypothetically, for example. That has to be instantaneous. So yeah, there's a conundrum there. There really is.
The lady who said that it would take the speed of sound for the stick to reach the moon, though, was pretty hilarious. But Bob, in the steel ball example that you gave, if you can, for lining up these steel balls for, let's say, to Venus, again, we're just thinking, if you were to swing one, wouldn't it instantly propagate on the other end?
Yes, but again, that's what I'm saying. You're comparing apples to oranges in an electromagnetic wave versus something that's solid.
But it just moved faster than the speed of light. Energy, the transfer, that you just broke the speed of light record.
Well,
the whole idea of being speed limit.
I suppose you could look at it that way. Yeah,
that was the point of the video, is to point out that the way they describe things, and they it would take 8 minutes and all this stuff, that makes sense. But there is things that we could easily mentally construct. Of course, we're not going to be able to find enough steel balls to go 22 million miles. But if we did, we know already just by the tests that we do here on Earth that it would propagate immediately, in which case you've just disproven Einstein and this theoretical speed limit.
Yeah, absolutely. So very good. Okay, well, it was an interesting thought experiment, and of course I could have a whole lot more comments about that, but I just did want to touch on it, just to kind of give you an idea of what I was thinking about it. But interesting thought experiment for sure.
It would travel as a wave, slightly slower than the speed of light, through the tungsten stick to the sun.
Yeah,
no, I'm kidding.
And well, that argument could technically be made as well with the balls, that would be a wave, because there would be some distortion on the matter itself. But again, this gets into physics, and it's not theoretical, it would actually be real. But I get the general idea of what you were trying to say for sure. But like I'm saying, I just had some I'm not so sure about that kind of thoughts. So
yeah, we really do need to stop playing by their rules, though. I totally agree, but I think that we still have some more points to score before we just totally go off the rails and start looking at everything strictly ipso facto as flat Earth reality, because there's just not enough people on board, frankly.
Yeah, there's just so many mental things you can do. I mean, even a laser light, and let's say it's powerful enough to hit the moon like the one they say they have. If you took that laser and you quickly moved it from one end of the moon to the other, you just broke the speed of light. The light that was on the moon would go faster to the other side of the moon than the speed of light. So there's ways that you can think out of their boxes that they've set. And I totally agree with what you guys are saying as far as why do we play by their rules? Because they set the rules and then they employ them at different times, right? When they want to use the idea of triangulation and they want to then they do. And when parallax doesn't work for them, then they throw it away. They just get to employ whatever they want when they want it. And then they explain it away as fact. And when you can easily disprove the speed of light just like that, or you can picture moons all the way around your head stretching in a circle, if you took a laser light and just wrapped it around your head, if that laser light hit every moon, it just went way faster than the speed of light.
Yep, absolutely.
Absolutely.
All right.
By the way, there's almost 800 people watching, and we've got 119 thumbs up to 19 thumbs down. So if you guys don't mind, if you're enjoying the show so far, give us a thumbs up. And if Snickers sues us, I don't even know who the Globebusters is.
Well, I think that video pretty much fits under the idea of satire, so I don't think they're going to be going there. Anyway, so all right, so let's go back into a little blast from the past. I'm sure you guys, I know Darren, you remember, but I'm sure you guys remember a guy named Dave Johnson, or Dave J from our past. And we've had say what, Darren?
I want their names, sport.
Yeah, I want the clickety clack.
Clickety clack shoes.
So for those of you who don't know who he is, Dave has been around for a long time, and he's an interesting guy, to say the least, I will admit. I think Dave is one of those guys, in my opinion, that kind of borders somewhere between the line of genius and insane. However, I will say that, he disappeared for over a year on YouTube, and when he came back, he seemed like he's really quite a different person, a lot mellower, a lot more collected and stuff like that, and I'm glad to hear that. Seems like he got a little bit more in touch with the spiritual side, and that's great. But he left a comment on last week's show, and this comment is exactly what prompted me for the subject of today's show and also the title of today's show. But, I've got it up where everybody can read if they want to. But, he kind of jibes us a little bit, saying, gee, here you are. You're still discussing everything on their terms. And I really took that to heart. All jabs aside, I read what he said and I thought about it and it's like, I hate to say this, but Dave, you're right. Okay. I even gave it a little heart because I really kind of resonated with his comment. And so it kind of prompted me to do the show on this. So essentially what he's saying is that here you are, you're still being pulled right back into their trap, their little abyss, and you are constantly being engaged on their terms, with their model, with their math, when we have our own observations, our own math that is every bit as valid for our observations, and all these other things. And I'm paraphrasing, what he's saying here, but the bottom line is I took it and it's like, what? He's right, and so we need to talk about this. And so I just want to give a shout out to Dave Johnson. Thank you for that comment, because hopefully, we'll explain our actions a little bit. In some part, Dave, I will reply with this. Obviously, part of the reason why we play by their rules is because, not only do we have our own model that we have to promote and kind of build up and show and try and prove and build a case for, but we also, unfortunately, are charged with having to debunk the heliocentric model, and that requires playing by their rules and their model. However, what a lot of flat earthers do is they make the mistake of engaging in these debates, and we are then subsequently given the math and model and the general idea of the heliocentric model and say, well, how does that work on flat earth? And obviously in a lot of cases it makes it pretty difficult to answer. So what I'm going to do is I'm going to go back also to another blast from the past, and I'm going to play a video by a guy named TJ. And TJ, his channel is Smokescreen Design, and many of you may remember TJ as being one of the original Globebusters many moons ago. And TJ made a video a long time ago that I have referenced on several occasions. But I think that you really, TJ's video, you really don't get the beauty of it unless you actually hear and see what TJ is saying in this. So what I'm going to do is I'm going to play part of this video, and I'm going to tell you right now, first of all, a little language warning, because TJ is not going to be our only instructor in this. We're also going to have a guest instructor by the name of Red's Rhetoric. And Red's Rhetoric, as you know, is a little bit of a potty mouth, so there's cover your ears on a couple of this. It's not too bad. But it's something that I think that, this video really makes a profound demonstration, and this is where we're going to start off after we play this video with explaining why it is important to look at our own observations, things that are actually real and empirical and observable, right? Kind of like, a long time ago when we were talking about, pilots and what they see and what they do, and the fact that, we as flat earthers, and I've said this and other flat earther pilots have said this, Chris is a pilot also, we never ever have to push the nose of that plane down to compensate for any curvature of the Earth. Well, so what we get as rebuttal for that, of course, is the ballers bringing their model into it, their gravity, saying, well, you never have to do that because gravity does that automatically for you, regardless of the fact that none of the instrumentation ever picks it up. They then try and debunk gyroscopes, which are very straightforward, very plain, and they try and convolute the whole thing. Go ahead, John.
Because I would just interrupt you real quickly and say, if gravity was doing all that, then we never would have needed gyroscopes, right?
Exactly. That is exactly right. And that was one of the points that we made on the episode a while back called Mathematics, Pilots, and Planes, Oh My, where we kind of went through the Wolfie 6020 model and kind of ripped it a new one. So anyway, so this is just one thing that I really think it's important, because TJ did a great job on this video, and I will kind of set the stage by telling you that Jaron and Red's Rhetoric had been in one of their many debates a long time ago, and of course, Red, being the person that he is, came out with a video and said, well, yeah, Jaron said that the moon is only about 3,000 miles up. Where did he get that? He must have pulled it out of his rear end, yada, yada, yada. So then he proceeds to go through the heliocentric observable model, right, and prove unequivocally in his eyes that the moon is 224 or 230,000 miles away, whatever it is, simply by using trigonometry. Okay, sorry, I had a brain cramp for the minute. So, and he makes his point and everything, but then TJ kind of elaborates on that. And so what TJ does is he takes the part out of Red's model that is simply unobservable, and that would be the curvature, and the curvature, of course, would represent the parallax in the equation. So that's the thing. We have never observed curvature, we have never measured curvature, so why on God's green earth are we trying to allow them to dictate their model to us, use their trigonometry, using their curvature? And then beyond that, we're going to go, after the video is over, we're going to touch on something that's going to kind of blow their own model away using their own trigonometry model. And so again, this is what I want to start pointing out. So everybody take relax for a minute. Jaron, there is a link that Mike has presented in the inside chat, the Skype chat, for you to look at. I know you've seen this video before, so you may want to look at it while we are watching this video. So this is going to be about 6 or 7 minutes, but as I said, this is going to be kind of a TJ and Red's Rhetoric being our instructors for the day, and I would advise everybody to pay very close attention to this, because this is important, and this is why I have referenced this video so many times on this. So here we go, guys.
We can find the moon's distance from the Earth is by using parallax. Parallax is why nearby objects appear to move more than farther ones when moving perpendicular to your line of sight with the object. And using parallax to find out how far something is nothing more than trigonometry. If you wish to find out how far away something is, all you have to do is follow this formula, and we will use this formula to find out how far away the moon is from the Earth. Now, the way we're going to do this is that YouTube user Jade, aka Turkey Cat, who's located in California, will be measuring the angle at which she sees the moon relative to the horizon. She will do this edge on with my location in Florida, and I will do the same while being edge on with her location in California. However, the first thing we need to do is find the distance between us. Lucky for us, the distance between us is known by, you guessed it, using the fucking ruler tool on Google Earth. With that, we now have the value of D, which is 2,351.81 miles.
Okay, so we need to take this 2,351.81, 2,351.81. Okay, 2,351.81. Okay, so just round it up to 82.
Now what we need is the angle at which we both see the moon. And here are the results. Jade makes her measurements and finds the moon to be 55.4 degrees from the horizon.
Okay, she sees the moon at 55.4. I'm going to put that right here, and I'm going to show you why in a little bit.
These measurements were done when I found the moon to be directly overhead at 90 degrees, edge on with Jade's location in California.
Okay, so his is 90 degrees. So we've got degree number 1, 90, and we've got her degree 55.4. So let's keep going.
With these values now accounted for, there is one more thing we need to take into consideration: the curvature of the Earth. Yes, that same curve that made the ship disappear from our line.
By the way, I did a video on this ship. This is complete horseshit. Red's Rhetoric. I can't believe you got fooled by this dumb-ass video. Oh my gosh, this video fakes so many people. Just watch my video on the ancient ship and just whatever. This doesn't prove nothing.
Seen previously. You see, as you get further away from a point on the Earth, the more deviation you will get in your visual angles. For example,
Now, I just want to make a point right here. If we're on the curved Earth, which fine, let's say we're on a curved Earth. Why is it when we fly, whatever, we don't ever see buildings leaning away from each other like this? And they have to, because certain parts of the Earth are curved away from others. So at some point when we're on a plane or we're on, some type of ISS, space station, when we're on something, at some point we've got to be able to see buildings that are curved away from each other.
Okay, I'm going to jump in and interject right there and kind of correct TJ. Actually, we know technically in the heliocentric model with the curvature of the Earth, yes, there would be a very, very small degree of leaning. However, even if you were right next to a building and it had a 1 or 2 degree lean, you would probably never even notice it. So let's just forget about that part. The rest of this is outstanding, though. Let's go forward.
But we never, ever see that.
Jade were to look straight up in California, and I were to do the same in Florida, we would not be looking in the same direction. There is a deviation there caused by the curvature of the Earth. How do we correct for this? Simple. A complete circle is 360 degrees. So if we divide the circumference of the Earth by 360, we will get 69.169 miles per degree of change. Now, if we take the distance between our two observers and divide it by that number, the miles per degree of change, we find that our visual degree difference is 34 degrees. So what this means means is that we will need to add 34 degrees to Jade's measurements in order to offset the difference.
Okay, so we need to offset the difference for the curvature of the Earth. So we're going to look at two ways. One is the Earth is flat. Doesn't mean a pancake. You look with your eyes, you see that there are dimensions up and down to the Earth. We need to make note here for curvature of the Earth, and we're going to do that. But what if the Earth is flat? If it's flat, then we don't need to do this. So we're going to see what the two differences. Remember, Jeranism said it's only about 3,000 miles away. And this guy says it's horseshit. If you use trigonometry, you'll see that is wrong. So let's find out.
Which, when we do the simple math, gives us a new value for Jade's observation.
So now Jade's observation, which she saw, was 55.4, right? 55.4. Like, nope, sorry, the Earth is curved. We got to add 89.4 degrees. So we have to make it to where I'm at 90 degrees and you're at 90 degrees, shy of 0.6. Let's keep going.
Value is 89.4 degrees. This means we can now find our parallax. Now, the inner angles of any triangle will always equal 180 degrees. So,
okay, so he brings us up that the angles in a triangle will add up to 180 degrees. So here we have angle 1. My formula up here up top. Let me pull this down a little bit. So you see that there's no formula in this box. Next box, no formula. And then this box, what I'm doing is we're taking 180 minus C26, which is this first angle, and then C27, which is the next angle, and it's going to give us the third degree, which is not masonry, but it's the third degree of the angle. So it's going to do the subtraction for us. Now, what also is going to happen down here, we have more of the formula, so C25. So it's going to take the distance, which is C25 right here, and then it's going to take the tangent and the parallax, and it's going to give us the mile. So we're going to see that here in a little bit.
We simply minus the total degrees we observed from 180 degrees, which gives us a parallax value of 0.
Okay, 0.6. Let's get that over here. 0.6, what he says, but it's actually 89.4. So what I'm going to do is put in 89.4 here. So these are the 2 degrees we're going to play with.
0.6 degrees. And finally, we now have everything we need for our equation to solve for x. So x will represent the distance from the moon to my location in Florida. So we simply plug in the values where they belong, crunch them out, and what do you fucking know? We found that the moon is 224,573.102 miles from my front door.
Okay, so it's 224,573 miles. Okay, so let's see what we get. Let's plug in 89.4 because we had to account for Earth's curvature, and there we go. So we have to account for Earth's curvature, which gives us a parallax of 0.6, which makes this 224,573.1. Is that right? 224,573? 224,573.1. Okay, so this formula works. But what if the Earth is flat and we put in 55.4 for this degree? We go back to her original degree that she had because we say, all right, what if the Earth is flat? That's what Jeranism says. Oh, wait a second. Now the moon is 3,409.143 miles away. So let me just ask you a question. Does the moon look like it is 3,409 miles away? Or do you think it looks like it's 224,500 miles away?
Now, that is the question, isn't it? All right. So what TJ has done here is he's taken Red Rhetoric's math, and Red Rhetoric is a rather famous ball earth figure for whatever reason. But, Red Rhetoric, used his math and really thought that he disproved Jaren in every way, shape, and form. But you notice that ultimately he had to figure in that curvature of the Earth, and that 55 degrees or whatever it was, or 34 degrees, that gave him the 0.6 degree of parallax was added in. Now, it was added in, but mind you, once again, we have never, ever been able to observe this curvature. We have never, ever been able to measure this curvature. So what we have been duped into doing is using this globe Earth, heliocentric spherical model math into determining what the alleged distance to the moon is. Well, so if we just stick to observable facts and quit making things up that are complete fantasy, like curvature of the Earth, well, then Jaren was right in the first place, wasn't he? It comes up to be 3,409 miles from Red Rhetoric's front door to the moon. And of course, this is very similar similar to the 3,415.9 miles that I have come up with, but we're not going to quibble over a couple of miles. And it also agrees with the throw of an object as light. If it would have to be 3,415 miles essentially, or 3,400 miles essentially above the Earth to be able to have a forward throw of light of 6,225 miles. And also, if you're going in the other direction, it would have to throw necessarily 6,225 in the opposite direction, which gives us 12,200 and 450 miles, basically half the circumference of the Earth. Okay, so isn't that amazing how that really works out? It works out in observable phenomenon, it works out in trigonometry, and it works out with distance to the horizon and light throw that is required to be able to light up half of the Earth at a time. Okay, and there's some other variables in there, but suffice it to say that unless we start adding in fantasy variables that simply have no basis in observable reality, Red's Rhetoric's formula falls apart. So this is what I'm talking about, guys, when I ask the question, why are we playing by their rules, right? It doesn't make any sense, and we fall into that trap quite often, and this is exactly what Dave J's point was in making this comment, and I really took it to heart. And there are a ton of other examples that we're going to get into on that, but I'll open that up for comments to the floor and see what everybody has to say about it.
Well, I really liked that video. Thank you, TJ, for doing that. I remember when you did that. But I think John always calls them scientists, and then I'll always call them mathematicians. And the reason that we say that is because of this exact reason. When they need the Earth to be a sphere, then they say it's a sphere. And when they want to use trigonometry and they want to say that triangles add up to 180, then they just ignore the sphere, and then they're talking about that being a straight line between the two ends, and it just becomes basically a disaster. And that's what they've always done. And that's the one thing when people say, "What are your credentials? Did you go to college? How can you think you know more than Neil deGrasse?" The scary part is what we're describing. The people who go to school, the people who spent 8 years in graduate school or whatever, are just going to be more firm in their belief in the math and magic. That's the problem, is that they'll know when to employ different things because it's being taught to them. They know when to say this, when to say that. They don't cognitively know that they're masking a lie, but it's just evident everywhere, and that's why I've gone on and on about the 0.318 before, is simply because it's an easier method to get the diameter if you've got the circumference, and the fact that they don't teach it tells me that there's something up with that. That's my only comment there. I definitely think you're right, though, Bob. The problem is that we always fall into using their trap to try and get out of the trap. It's just not going to work.
Well, and this is what they've been doing since Eratosthenes, right? And this is the original argument, is that, if you assume that the Earth is a sphere, then you can make the numbers work out. They've had hundreds of years to put their values together, and I always thought the moon was a little bit more distant than they got there on average. But that's the whole thing. Eratosthenes assumed the Earth was a sphere and used the Syene to Alexandria experiment, and this is old news. I mean, we know that this is the same trick they've been doing to get the alleged circumference of the Earth as well as the distance to the sun. But you can plug the numbers into either a hypothetical plane or a hypothetical sphere and get two totally different things. And you mentioned a good point too, is like a lot of people ask, what are your credentials? And I think that a lot of times that credentials work in the opposite way in which we may think. Somebody that is highly credentialed is merely more highly indoctrinated into these hypothetical figures that work mathematically but don't match reality at all, right? And I would say that something that is not credentials is using pre-built formulas and the aid of calculators to make yourself seem smarter than you are, and that's probably the case with people like Reds. So I'll pass the mic, though.
Okay. Anybody else have any comment on that? All right. Well, then... go ahead, Antonio.
Sorry, Bob. I have a comment. Sorry, my Skype dropped. I was a little bit disoriented. On the back of what Jaron and John are saying, if you got somebody who went to a seminary school to learn all about worshipping a lizard god, okay, or a tree god, whatever they taught you would be from that point of view, the tree god view. Whatever happens and the tree god decreed this or decreed that. This is exactly what happens with the pataphysics that these guys learn in astrophysics. That's what happens. It's the same thing. They have this belief installed, and that's how they see the world, and that's how they talk about the world. And you can't debunk it. You can't say the tree god doesn't exist or the lizard god doesn't exist, other than and by demonstrating stuff where you know that you can show that what they've said does not work. And this is we're seeing it coming up on the 21st. There's all various different ways where it does not work. There's a few ways you can look at it and say, oh yeah, the tree god's making it work. But you look at all the other ways in which it does not work, and they have a problem, which is why they limit the discourse to their conversation, which is what the message was saying.
Right.
If we argue by their rules, then we're locked to where it works. Let's look at the things where it doesn't work.
Right. That's exactly right, Antonio. Because what all the things that we're being taught at university and in school, high school, junior high school, elementary, it doesn't matter. Anybody that's been to school knows certainly that what school is really about. It's not. They don't teach you about critical thinking. They teach you basically how to replicate and repeat things. In other words, this formula that Red just did, this is part of trigonometry training. Well, this is the formula. This is how you have to do this. And of course, in order to do this, you have to take the parallax of the Earth in, because obviously there's going to be a distinct angle change, they tell us, between Florida and California. Well, that's one of the tests that I just did in Hawaii with the accelerometer, and whether people want to admit that it doesn't, the accelerometer does not work based on gravity or not, but rather it works on inertia. Nevertheless, the result that I got is the same the result that Paul on the plane got, and that there was absolutely no change in orientation between Denver and Hawaii, which there should have been 47 degrees of change. And same thing goes for Paul on the plane when he measured between Seattle and I believe Scotland, which would have been probably 60 plus degrees of change. We can't measure it no matter what we do. We can't observe it. Every experiment to ever do so has failed. Instead what we get is ridiculous stories like, the ship over the horizon arguments, yada, yada, yada. It goes on and on and on. And this is how they bolster this argument. But again, remember, these credentials come, basically you get your degree by being able to regurgitate back what you have been taught verbatim. And if you don't do so, or you rock the boat, then you fail. So that's kind of the thing. So you're right, Antonio, absolutely 100%. So what I want to do then is let's just take this a step further. And let's keep it in the realm of observation, all right? And let's just say Red's rhetoric was right, okay, and there is this 0.6 degree of parallax on the Earth. And let's take, and since we have the sun and the moon in the sky, and they are both, of course, the same apparent size, we can do that very, very same trigonometry on the sun. Absolutely we can. And if we were to do that, what do you suppose is going to happen if we did that trigonometry on the sun between California and Florida? Well, I can tell you what it's going to come out to be. It's going to come out using Red's own formula and observation, measuring angles to the sun. It's going to come back showing that the sun is also 224,000 miles up. Whoops.
Yes.
That's a problem.
Yes. That's what you just said is something that can be taken to any mathematician and just put to them. Say, look, this is the situation. This is the basis for why you think you're on a globe. You can't have 93 million miles and 234,000, 100,000. You can't. And, well, like you just said, the equation that says one distance for one thing is the same equation for the distance for the other thing, and it's the same degrees arc anyway. Yeah. So it is definitely, both same distance.
Yes, absolutely. So that's, and that, of course, is using their own formulas, their own observation, their own trigonometry. And, of course, if we modify it and take that parallax value out and make the Earth flat again, what do we get? Well, we're going to get the sun also is at 3,400 miles, which is exactly what the flat earthers have been saying all this time, right? But, then all of a sudden...
I have to sort of disagree with that value because starting with Eratosthenes and including Rowbotham, all of this triangulation was done in complete ignorance, for lack of a better word, of the atmosphere or the atmos plane and how that affects light waves incoming from the celestial areas. And we know pretty damn well 100% that refraction is causing not just parallax not just perspective is causing the sun and moon and stars to rise and set. And so just now, as of 2017, are people starting to model these things and take these triangulations triangulations and factor in the atmosphere, which does behave as a subjective convex lens. And at this point in the game, we just don't know what the sun and moon are. We don't know how distant they are. We can make assumptions, and we can draw assumptions based on triangulation, and that's great. You know, we've had these values since the late 1800s or the mid 1800s when parallax did them. But when, you know, they're totally failing to factor in I believe one of the biggest variables, which is that of the atmosphere, then we're left, you know, we still have some more digging to do. I don't think we can just settle on that angular size and distance to the sun and moon.
Well, I don't think anybody's saying.
Sorry,
I was just going to say I don't think anybody's saying that, and if they are, then I missed that. But you know, he's basically showing you that you know, the way that Red's rhetoric is doing it, that you can come out with different values that, like you said, John, are the ones that match the ones we've had since the 1800s. But you're totally right. I mean, I certainly don't believe that the moon or the sun are 3,300 miles away.
Well, it would be easy to test. All it would take is for people to do the same test as Reds did with the moon. It doesn't have to be at 90 degrees from Florida, or just two people in the daytime moon. So when the moon is seen on the blue sky, and see what the difference is with where the moon is.
Right. Okay. And
on a black sky on the night.
Yeah, I agree with what you're saying, Antonio. But John, I think John's point was, and John, I totally get where you're coming from, because there are obviously other factors. But unfortunately, until we figure out how to quantize those other factors and then fit them into our own calculations, you know, we're kind of left at the mercy of making strictly simple observations. Now, the reason that I think that 3,400 miles is probably a pretty good figure, and like I said, I've stated this a million times, is because it pans out when you are doing a distance to the horizon and you get that 62.25 in each direction. Now, I'm not saying that there isn't some other factor that could be greatly distorting that, but we don't know how to quantize that. We don't know how to measure it, and we don't know exactly how to determine what that is. So, yes, that's going to cause some problems, but...
Well, if we had a budget like NASA, we could send up 3 very high budget, even if they were $50,000 a piece, weather balloons, and do some triangulations at really great distances from above the troposphere, and I think that would give us a tremendous amount of data. But instead, you know, we shovel $52 million a day at NASA so they can lie to us and make frickin' ridiculous videos.
Yeah.
Also, guys, you know, there's been a couple of people saying, pointing out, this is really simple. All we need to demonstrate what we're talking about is to have 2 teams sailing, one around the north and one around the south. That's it. We don't have to cross the, you know, 55th or 65th or whichever degree they say we're not allowed to go by. Circumnavigate the Earth around the south and circumnavigate the Earth around the north. There you go.
Yeah.
And compare.
Yeah. Well, there's even easier ways to determine that, but that's coming. That's coming. And I won't say any more than that. Let's just put it that way.
The other thing I want to mention is just so we're careful about something. I've been reading the Principia, and everywhere I can find Newton discuss the equator, he's coming out to 22,200 miles for the equator. So make sure that we know that going forward, because they may try and say, okay, they sail the, let's say they go towards the Tropic of Capricorn, and they say, oh no, we sailed this and it's even further. Well, that's because the equator is not as big as you say it is. So just be careful on that one. It looks like the equator is 22,000 something miles, which would be even more ways that they could, manufacture this whole lie.
I wonder if he was using nautical or statute, though, because that would pretty much bridge that gap there.
No, and I think he's using statute based on other distances that he's talking about when I looked at the distances between locations. But you'll notice that they try and do that. They'll throw that little curveball at you, because same thing with Mercator and these guys, they'll just mention, well, it wasn't Mercator who wrote his book, but I'm sorry, not Mercator, Magellan. The guy who wrote his book, he explains exactly at the end of how far they went in statute miles, but you'll still see it if you go search Wikipedia or something. They will mention it as if it's nautical miles, but he definitely says in the book that he's talking statute miles is the total distance that they went. So I know what you're saying, but when I looked at other distances between locations, it seems like he's always talking in statute miles.
And that's interesting, though, because it does give them sort of a plausible leeway, doesn't it? Because they can actually take their values and just transpose either statute or nautical miles and get it to work. It's pretty weird, but okay.
Yeah, totally. What is could you describe the difference between them? I mean, I'm not saying the numeric difference, but why?
Like when I figured up in my head, I figured up as like 1 to 1.1 or something like that. A statute mile is a little bit less than a mile, right?
Yeah, but I'm wondering why do we have both? What is different about being on the ocean than being on land that they would have nautical miles?
There's a reason for it. I forget exactly what it is, but I just know that nautical miles add up to a little bit more, and statute miles are a little bit longer.
Yeah.
I think it has. What does it have to do with like the angular velocity or something? I forget, but there is a distinction between the two.
Yeah.
Well, guys, when we were at school, we were taught. I'm sure you were all taught the same, that the equator was 24,000 miles. Now it's nearly 24,900. It's like, is this how they blurred the lines? Is this how they went from a 3 million mile distant sun to an 86 million? Do you know? So we have no way of ascertaining what the diameter of the Earth is based on their calculations, because their calculations are based to support their mathematical model.
Right. So
yeah, that's true.
I have a question really quick for you, Chris. As everybody knows, you are a surveyor, and you are, I believe, a plane surveyor, right? Would that be correct?
Yes.
Okay, so in comparison, as far as numbers of actual surveyors on the ground out there surveying the world as we know it, would you say the great majority of the surveyors out there are actually plane surveyors, or would they be geodetic surveyors? And if it's plane surveyors, how many more plane surveyors are there than geodetic surveyers?
I would say that there's probably quite a bit more plane surveyors than geodetic surveyors, because geodetic surveyors are basically what sets up the WGS 84 and state plane coordinate system. They're the ones that come up with that mathematical construct.
Right, that nobody can see in the WGS 84. And the reason I ask this is because I'm sitting here watching the chat, and we have one of our favorite trolls, Charlie, in the chat, and he's making a comment back to Antonio where he says, Antonio, perhaps so. Is this surveyor a specialist in geodetic surveying or plane surveying? If the latter, no real point. In other words, what he's doing, he's just saying, plane surveyors, we're just going to discount them. They mean nothing. They're completely irrelevant to this discussion. And to that, I say that is about the most idiotic statement I have ever heard in my life, especially when you have the majority of plane surveyors out there that are really doing the work, really doing the actual differential leveling and equations and stuff like that. I just can't believe some of the statements that come out as a result of cognitive dissonance or trying to push a model that they're being paid to push out of some of these trolls. So I just wanted to ask that question because I suspected that there were probably a ton more plane surveyors than geodetic surveyors.
Yeah, and something else I'll add in is I've been thinking about this. It's kind of like, if you were putting like a tile floor in your bathroom or your living room where you have 1 foot squares and then you put them side by side by side by side and you have a flat level floor. Basically, that's the same as plane surveying. We survey out a mile by a mile area, and the next area next to it isn't any different than the one next to it, the one next to it, the one next to it.
Yeah.
Can I ask a question for you, Chris?
Sure.
Okay, so do you use like a theodolite when you do this?
Yes.
Okay, and
theodolite and GPS.
Okay, and do the theodolites, do they still use a convex lens?
Yes, I believe so.
Okay, because I was just having this sort of argument again in chat the other day with somebody who comes up as a surveyor. They say they see. If I can share my screen real quick, that'd be awesome. It'll just take a second.
Yeah, hang on just a second, John. Let me prep that.
Okay. And
Charlie, in the meantime, you're saying a plane surveyor does not measure the shape of the Earth. That is not their job. They set things up on a plane. Like, oh, wow, this is what we're discussing. That they set things up on a plane because this is a plane. The other guys are just theoretical. This dude doesn't. Yeah.
Well, it's what he's paid to do, Antonio. Everybody knows Charlie's a troll. Everybody knows Charlie's paid to do this. So, Charlie, you got to understand, you're not convincing anybody of anything. People just kind of look at you for comedy relief, and because nobody's really buying what you're saying. So, but anyway, knock yourself out. Go ahead, John. You're ready to screen share.
Okay, and so this was an argument that I think was very well done done way back in the 1800s in Zetetic, and I had assumed for this whole time correctly, because I did look into it, and I had just assumed that 2017 was no different than 2 years ago in a sense that theodolites use convex lenses. And so and this is even what Robotham was arguing, even testing the equipment, is that if you level out your theodolite, because of refraction in the convex lens, you get this sort of apparent drop of the horizon line, only through the lens, of course, compared to whatever you're leveling crosshairs or whatever that true level is. That is due to the refraction of the convex lens, has nothing to do with the curve of the Earth, and yet there are still surveyors that are making this argument, and I just wonder if you might comment on that.
Yeah, and one of the
you
things
can stop sharing or keep sharing me, whatever.
Yeah, actually, John, you never shared.
Oh.
You want to try it again?
Do I need to, do I have to physically share my screen?
Yeah, you have to hit the plus button and say share screens on Skype.
Here we go. Okay, here we go. This way everybody can see it. Righto.
Okay,
so start.
Let me tell you.
Here we go.
There you go. All right, now we got
So that's what I'm talking about here. So if you've got a theodolite that's leveled out to the ground, so you know that the thing's level and it's facing the horizon, which you know is a certain distance based on your elevation, what surveyors are seeing is the horizon apparently drop a little bit. This is probably exaggerated to show the point, but the surveyors are seeing the horizon drop a little bit compared to the level, which is indicated by these crosshairs, but only through the lens. And so I just thought maybe you could comment on that and its accuracy, because I always thought it was a fabulous argument from Robotham, not ever me personally using a theodolite. So just your thoughts on it, maybe.
I've kind of expressed this quite a few times that let's see, how would if you're just slightly off level, let's say that it's 100th of a foot off level where you're standing. So the further you project that out, the bigger the gap is going to be. So I don't think, in my own personal opinion, that a theodolite is accurate enough to do the measurements that they're doing, the geodesists. And then I believe that geodesists kind of fall in the same category with astrophysicists. They're handed their mathematics and they go out and they make observations, and their math concludes that there's actual Earth curvature through their math.
Right. Yeah, that rings true with me, and that makes a lot of sense why you would have surveyors coming out and saying, well, we know the Earth isn't flat because of this or whatever reason, but they are slaves to their own hypothetical numbers, slaves to the construct, because they can't think outside of the box to say, well, what if the Earth's flat and this is just refraction, right? So
right, or heat waves. Heat waves take a lot of it, because all the transits are focused out to infinity.
Right. Okay.
So it's not like a zoom lens on a camera where you can bring in from 200 millimeters to 500 millimeters. They're focused to infinity, and when that happens, you bring in all that atmospheric distortion.
Gotcha. Okay. Interesting.
Okay. Great. Thanks, Chris.
I think it's even, and I don't know if this is the best time to bring it up, but there is a large issue that I think is going to come up in the future, and people probably should start looking into it. But kind of what you're describing here, John, and it's also from Robotham, when the Bedford level experiment didn't go as planned for Hampton, that was because when you looked out from the bridge and you had these, let's say these poles at 10 feet high off the water tops, the reason he lost the so-called bet was because in the telescope, those poles fell down in the distance, and they called that the curvature of the Earth. And then Robotham came back and stated, and this is one when I've told people, they're like, what are you talking about? That if you line up a telescope and level it from your position and then aim it, or it's leveled and it's hitting the top of those 10-foot poles, that those poles will fall down in the eyepiece of the telescope, and people will say that that's the curvature of the Earth. And what Robotham was saying is it is not. You need to actually tilt the telescope to hit the first and second pole, the tops of each, and then if that line stays even with the telescope or the telephone poles all the way down, then the Earth is flat. This is the whole thing that got the Bedford level experiment on a crazy one. And I was trying to explain it on Raw last week, and Missa was kind of at a place where she was starting to see the whole idea of the Earth being curved by that experiment. What I eventually had to do to get her to see it is I said, imagine you put a telescope level up on top of a cloud. Okay, so we know that the clouds in the distance go down to the horizon, but that telescope placed on top of a cloud above your head, if it was level, would shoot out into space. It would not follow the clouds as they go down to the horizon. That's a much bigger example, or a much wider kind of metaphor, but really that's the same thing as us on the ground. That's why theodolites measure drop. is because you're looking through a telescope, and items I don't want to say in reality, but to us, they get smaller as they go towards the horizon. Well, a telescope cannot, the same thing doesn't happen to a telescope, because just like in your picture here, all the telescope sees is this circle, right? That's all it sees. It can only go into that circle and come out of that circle. It doesn't see anything more than that. And so if you had poles going down all the way to the horizon, it dropped per the crosshairs, kind of like you're showing here. It's a combination of both. But I think that's going to come up, and that's why I wanted to do my experiment by the lake, because it's going to show when we shoot the laser through and hit the wood planks versus when we send the theodolite through, that the theodolite will eventually, in my opinion, see wood, because it's going to show a drop, but it's not a drop.
Yeah.
That's an excellent point, Jaron. And you can do the same thing with the camera. If you set up a camera and if you pick out something far off in the distance and you start zooming in, you have to pull the camera down to bring that back into the picture.
Yeah. Oh, okay. And Chris, real quick, speaking of wood, we have had a request from the chat for you to describe your instrument. And LOL, what I mean by that is Adam AJC, our guest last week, basically made a suggestion, a request, if you could describe a little bit about what the theodolite does and how it works, just for the benefit of the audience.
Basically, it's just a telescope with crosshairs in it, set up with now it's all digital. The levels within is all digital. But basically, you have a level bubble that's in both directions, so that you can level it perfectly in all directions. Basically, it's just a telescope with crosshairs built into it.
Okay.
And I will say, throughout the years here, in the last 7 or 8 years, the equipment and the theodolites they're giving us, it's you used to be able, with the older stuff, you could go 1.5 miles, 2 miles if you didn't have lots of heat waves. This newer equipment, we can't go more than like 1,400 feet with the optics, and they have degraded the instrumentation that we're using.
Wow, really? That's pretty counterintuitive.
That's amazing.
Exactly.
And one other thing that I'd like you to clarify, Chris, because this is something that it amazes me that people make this mistake, but I'll just make the statement and you tell me if I am correct or not. Theodolites do not measure curvature. They do not measure arc. They measure slope, and then from that resulting slope measurements, you use your trigonometry to then calculate your elevations. Would that be a correct assessment?
Yes, that's spot on.
And GPS, right? You have to use GPS in those measurements.
Do what now, Jaron?
Do you use GPS as well?
Yes, I use GPS whenever we do really long projects, or we want to go out and shoot like I was on a big project that was 60 miles long. We use GPS because you can go 60, 70, 100, 200 miles with GPS over long distances. Really quick measurements with GPS.
Yeah, and Chris also has some really interesting stories about what he's found out about GPS by some of the people that he's talked to in the field, but maybe if we have time, we can go over that a little bit. But every time Chris comes over, he's always telling me some really interesting stories that he finds out. And of course, these are the experiences that he has that are part of many experiences and tests and measurements and stuff that has built his preponderance of evidence, and the reason why he calls himself a flat earther. So, like I said, guys, we don't come to these realizations or these conclusions about the shape of what we're actually standing on just arbitrarily. It usually takes several things. It's a composite, a preponderance of many, many things. So that's how it's done. So there you have it. And Jaron, you just shared a photo. And John, you're still screen sharing. Are you done?
Yeah, I'm done. I can stop sharing if I knew. I don't want to hang up the call. No, stop sharing. There we go.
Stop sharing. Nice. Yeah, pretty easy. All right, let me go back to the splash. And Jaron just shared something. Where is it? Good grief. Okay.
I was just pointing out the
to Mike. Okay. Oh God, you guys.
Oh no, we've been talking. I shared the picture of the theodolite down there, and just all the different screws and the auto collimator devices, and there's so much into it. And I thought it's funny because the way that Chris just described it, he said it's basically a telescope with crosshairs built in, and that's a way of describing it, but it's got so much more into it. And I think that's the issue, is that it seems like there's an awful lot going on in there, and like Chris said also, that if they had the mirrors, 1/10 of 1 degree offline, that the results would tell you that the Earth is curved. Just it's that simple. It would be that easy to do. And I'm not saying that that's the case because I don't know, but there's awful lot of you see in there. There's the retostat. There's the different screws. There's just so many things. And like Chris said, that the slightest little bit off. And I watched this guy do this presentation, and he said, and I think it was over 10 meters or maybe it was 30 meters, but he said he had to come within 5 millimeters of actual level to be considered correct. And the problem with that is that if you multiply that out and actually it grows exponentially, that over the course of a mile, you could be off by 30 feet. So that was something I figured out and just said, well, this is ridiculous. I mean, why? But I understand why it works is because they're doing small locations and treating the Earth as a plane, in which case you're going to be fine.
All right, there we go. Yeah, I've got that picture up in the on the share. You guys should be seeing it on Skype as well. But man, that looks like an old-timey one. Is that a really old one, Chris? Or that doesn't look like anything I normally see the surveyors using.
Yes, that's extremely old. Like I said, the ones we have nowadays, all you have is your eyepiece. You level it up, and basically it's just a telescope with crosshairs in it that are extremely accurate.
All right.
Are you talking about an electronic one? Does he have an electronic one or just a non-electronic one?
Yeah, the one that I use is actually robotic. Nowadays, you used to have somebody standing behind it to turn angles and stuff, and nowadays it's all robotic. It communicates with radios and laser lights. You don't even have to have anybody standing behind him anymore. You can go out by yourself and do all the work.
Yeah. And Chris, you've been doing this for 30 plus years, is that correct?
Yeah, right around 30 years.
No, there you go. I'd call that a veteran for sure.
And then just something else I want to throw in. When I first started looking into flat Earth, I went into the office with everybody sitting there one day, and I asked everybody, what is the equation for calculating the curvature of the Earth? And everybody looked at me like a deer in the headlight. Nobody could answer the question, and I think that says volumes about not using the equation for Earth's curvature for anything that we do.
I don't doubt that a bit because, as I told you, I used to build point-to-point microwave systems all across the country. And, I was a field engineer actually out there in the trenches building them. And, we had calculations for Fresnel zones, for, date and backup, redundant receivers in case you got any path fade, anything like that. But again, when you're doing it, you don't ever think about the curvature there, even though it is plotted out, guys. So don't hit me with that. I am aware of it. It is plotted out. But, when you're actually in the field and doing the field engineering, it seems logical to you because we're always either on the highest ridge on a plane or, we have the shot taking place from a mountaintop or whatever. So you automatically think that that's the thing that's going to get you over any obstruction. But I have to tell you that I never, ever, ever knew about the 8 inches per mile curvature, or even the Sagitta or anything like that, that involved dealing directly with the mathematics of the curvature of the Earth. So that just goes to show you that, regardless of the fact you're working in the field and are actually, a professional in it, there are just some things that you simply accept on face value because you were told so, and the fact that, it's working, right? So why would you ever want to question it? So I sympathize with your other surveyors that they don't understand that, and I'm sure you probably weren't ever really taught that either, were you, when you were first learning about it?
Absolutely not. It was never mentioned in all the years of the survey.
Yeah. So
the only time it comes up is when we're working in the state plane coordinate system, and basically all they're doing in the state plane coordinate system is scaling distances up and down.
Yeah, absolutely. So, all right. Well, that just goes to show you, and this is what we were talking about earlier. This is the education system for you because they teach you what you need to know, pretty much bare minimum, because they certainly don't want to give you any more information than what you could possibly use on whatever career you're doing, because heaven forbid you figure out something else that they don't want you to know about. And this is something that absolutely happens. So and Life of Riley, yes, we're going to be talking about the Eclipse Challenge. I'm not sure which Eclipse Challenge, unless you mean the one on Facebook, but if not, kind of elaborate on that. Anyway, okay, so let's go ahead and move forward, and let's get to the Eclipse eclipse part of the show. And I guess, Antonio, we'll start off with a couple of the things that you discovered this past week. And believe me, I've been watching the trolls just bear down on you very hard. So I always find that interesting because that tells me that somebody's right over the mark when you get swarmed out by the trolls. And again, like I said, this is kind of my weak area, but I do follow along as best I can. And a lot of what you're saying does tend to make sense to me. So if you would you kind of go over that with what you have discovered, and then we'll go over and talk to Mike about what he has to share with us, and kind of open this whole thing back up on the eclipse dialogue again.
All right, cool. For globings out there, okay, so Charlie, the diameter of the Earth is 4 times that of the Moon. The Moon's diameter, the Moon transits through its diameter once an hour. That's half a degree. For it to cover the diameter of the Earth, that's 2 degrees. That's 4 hours. There's no arguing with that. 4 hours covers the diameter of the Earth, okay? The eclipse is going to be, depends where you look, from 5 hours 18 minutes to 6 hours and 23, various different amounts, okay? The eclipse is going to be visible from this place in Russia, in East Russia.
Because I just want to stay with you. And you said for the diameter of the Earth is 4 hours. Explain to me what you mean by that.
So the Earth's diameter is 4 times that of the Moon, and the Moon covers in the sky its own diameter once per hour, and the Moon's diameter is half a degree. So if you break it down into degrees, the Earth is 2 degrees and the Moon is half. So every hour the Moon covers its own width in the sky, and that's 4 hours to cover the width of the Earth. So start to finish, that would be 4 moons. So moon next to moon next, 4 of them would cover the surface of the Earth whilst it's blocking out the sun. It's 4 hours. But the eclipse is going to happen for at least 5 hours. I mean, that's just what they say. But when you look a bit deeper, you see, actually, the eclipse is going to start being seen from eastern Russia, So it's going to start being seen from eastern Russia. It's already going to be seen eclipsing. So it has already used up some of its orbital movement, transit period over the Earth. It's already using some of that 4 degrees of shadow casting by the time it rises in eastern Russia. So now it has less than 4 hours to cover the surface of the Earth. But somehow it's going to take, depends where you look, like I said, from 5 hours and 18 minutes to, they classify this as where it's going to be visible. So middle of the ocean, they don't class that as visible. So what are they doing? Now, when you take this and you plot this on Google Earth and you take a look from Google Earth, you see big problems. And this is what happens. You go to one point, you say, okay, the sun is rising here. Now you take it 4 hours, see where the Moon would be casting its shadow. You see, that's not where it's going to be casting its shadow. That's the globe. By looking at the eclipse through Google Earth, you start to unravel Google Earth. So when you get people like Steve Torrance, who's really meticulous. Now, I'm not meticulous. I'll hold my hands up and say I am absolutely not meticulous. Not with things like this. I always think in terms of give them lots of send a lot of stuff out there, have the trolls coming, because they know that they're troubled, because they know that some of it sticks. It's like, dude, look, not enough hours for this, or it should be a lot more hours. Whatever it is that you're showing with their own model is a problem for them. So if you look at Steve Torrance, who is meticulous, who's made a video with the Moon at the exact distance on the 21st of August, and you look at the shadow that it casts on the Earth, you have something that's very different to what the real eclipse is going to be. Now, this is him modeling the globe with the globe's moon, with the globe's sun, and you have a big problem for the globe. So all that I've done is, just
because I'm still lost, and maybe you can explain to me. When you said that the Moon moves its own diameter in an hour, I mean, that's wrong. I mean, I can, the Moon's up in the sky. If I take it and copy paste it, it's going to take way more than 12 to go across the sky. The Moon's not
absolutely. Oh. This is only their version that says it's half a degree per hour. It comes down from their mathematical concept.
Are you saying the Moon goes around 360 degrees in a day?
No. no. According to them, the moon covers in its orbit 13.17 degrees. That's on a sidereal orbit. So in one day, it covers 13 degrees. Half of that is 6.5 degrees. The eclipse can only possibly happen over a period of 2 degrees. So this is what I mean by it starts to unravel.
Got you. I got
so
you.
If you take, yeah. So you see, it's like, hey, hold on a second. What's going on here? And they will twist their brains and say, look, what's happening is some of those degrees that the moon goes around the Earth. If you start a timer on the globe Earth, well, some of it is already happening before the eclipse happened. So this is how they get away with, well, okay, if it was doing what we say it was doing, then it would take much longer to eclipse. It's not going to take much longer. So they drop that and they move on to a different set of parameters for their mathematics. So they use the real world and translate it into one form of the mathematics. They drop the orbits of the Earth around the sun. They drop that. They drop a whole load of things, and you end up with something that sounds like it's going to reflect the real world. But if you then take what they're trying to portray as reflecting the real world and transpose it back onto their globe, you see it doesn't. It doesn't work with their globe, which is Google Earth. It really doesn't.
Can I interject with Antonio here?
Yeah.
What Antonio is saying, and I put a picture up to explain it as simply as possible. The moon has but a 2-degree area out of its whole circumference path to leave a shadow on Earth. And what Antonio was saying, that shadow must start over somewhere in Russia, taking up some of the times that we will see that eclipse in America. And so what Antonio is saying, in this little 2-degree span, that is the whole shadow across the Earth. However, in America, they claim we will see the shadow just in America for up to 5.5 hours, which is an impossibility when you model this to scale. That's all I had to say.
Yeah, and then
so where is the report of that? Where does anybody see America will see it for 5 hours? I don't see that anywhere. I see an hour and a half. This is where I'm getting confused at what everybody's saying. Clearly, the eclipse starts in California at like 10, and it's done on the East Coast at like 12:30, or maybe it's 11:30 my time. So that's like an hour and a half or 2 hours. So where's anybody seeing any evidence that it will be seen for 5 hours across the United States? If you could just, Mike, can you put up an image of something showing that's the case?
Right. I was just looking at sites of what they claimed.
That's what I'm saying. So just show me an image of science claiming that, because I have not seen that. I've heard a lot of people claiming that, but as far as when I look, I see an hour and a half or maybe a little bit more.
What they've done, Jaron, is on time and date, they said this is where the eclipse would be visible, and it gives you a range of places in the US, and then it gives you a different breakdown and says this is where it would be visible in its totality, but it doesn't give you a breakdown of where. It's at that point that it's 5 hours and 18 minutes. It doesn't tell you where. It just says this is the period that it would be eclipsing the Earth. It's on the it's a second table on time and date under the eclipse. So one gives you a list of cities.
Antonio?
Let me see. So that's it. And all of that is UTC. So you don't need to, factor in different hours and, time zones. It's all UTC. That's 5 hours and 18 minutes. But notice it doesn't tell you where it starts and where it ends.
Well, that's across the entire Earth, right?
Well, that's the thing. It can't afford more than 4 hours. This is already saying 5 hours and 18 minutes. And given that it cannot afford more than 4 hours and that it rises already eclipsed, it's already used up some of its 4 hours of possible eclipsing time.
What do you mean by it rises already eclipsed?
So in eastern Russia, which is the first place they see it, as the sun rises, it's already eclipsing. It's already being eclipsed by the moon.
Oops, Antonio.
So this is in a place called Apuka. Yeah.
Okay, so we have it right here on the chart. And Antonio, you are dropping in and out just a bit. So I don't know if you have anything you can close in the background. But here's the time and date showing Apuka, Kamchatsky, and Krai, Russia, and all that.
And if you go to time and date, you see that in Apuka, it rises eclipsed.
Okay, we missed a chunk of that, Antonio. You're getting kind of choppy.
Let me come back in.
Okay, yeah, you might want to reboot your DSL modem or whatever and come back in.
I would probably just mention real quickly too, since the theme of the show is why play by their rules. We really do have to swallow a lot of theory in order to go with the heliocentric version of the eclipse eclipses. And if it turns out it's geometrically not possible, as they say, then I think that will be a huge win for flat Earth. But I mean, we have to swallow orbital mechanics. We have to swallow gravity. We have to swallow these distances to the sun and moon. We have to swallow the sun behaving fairly peculiar. I think we did mention Eratosthenes' values and experiment in this very podcast or whatever. And so this the factor of eclipses or the shadow of the moon or whatever the obstruction is getting smaller as it gets close to the Earth. That is in stark contrast to the parallel shadow angles that we necessarily have with Eratosthenes and assuming the curvature. So there's a big sort of conundrum or contradiction in the heliocentric theory right there. But yeah, we have to really, really just gobble down a lot of theoretical nonsense to go with the heliocentric version of the eclipse. And I'm really curious to see how the eclipses model out on a flat Earth. But again, in order to do that, we really would have to know what the actual distances, sizes, speeds, locations, and everything of these objects, if they're even objects, right? So,
right. That
my
makes
two
sense.
cents.
Yeah. And while Antonio is working that out, I'm also going to throw in one other thing that Chris and I were talking about yesterday, and I brought this up last week, Jaron, and I hopefully got my point to you across in the chat the other night about, because of the fact that the sun and the moon are the same apparent size in the sky, that is akin to having, the two light sources basically right next to each other. And if that being the case, then we would expect to see something more akin to what I'm showing on the screen right now. And this is something that Luke Flat Earth Consequences brought up over a year ago, so I want to give him the proper credit for it. But it doesn't make sense to me, again, that the moon could possibly be throwing a smaller shadow than itself down onto the Earth. Now, Chris Van Maitre has done some really great experiments, and what he found, and I'll let him talk about this in a minute, is that in order to make this actually happen, and Luke also covered this, is that you have to add some sort of magnifying element in between the sun and the moon, or the moon and the Earth, and that's the only way that you can actually focus the shadow down, which is really weird.
Let's pretend that this black bar on the right of the screen, that is the sun.
Okay.
You can't pretend that the dot is the sun. You have to pretend that huge black bar is the sun.
Okay.
And so from our position on this wall, when you're looking at the moon, it's blocking, because of its distance, that entire black bar on the right side.
Yes.
Now, there's still light that comes from the top of that black bar on the right side and hits so there would be no shadow on the top there, because the light would be hitting it. I mean, this is what I'm saying. You're describing it incorrectly when you show a little tiny light source.
Well,
that's not what the sun is.
Yeah, and I actually brought this up over 2 years ago. One of the very first, I think it was the second Flat Earth video I ever did. I actually forgot to put the animation in, and so I actually did a separate video with just the animation. But the animation showed that we should see a conical, not an inverted conical, but a expanded conical shadow coming from the Earth. And I just thought it was really funny because I got lambasted with comments by people saying that, don't you know anything? You're supposed to have your shadow as an inverted cone, not like a tapering off cone, not a expanding out cone. Or according to Eratosthenes, in order to make his values work, then the Earth should technically be casting a perfectly 8,000 mile diameter shadow through space. And if that was the case, then we should see lunar eclipses far more frequently than we see solar eclipses. But we don't. Over 100 years, it's about the same. So go figure. Yeah.
Mic test.
Yeah, we hear you, Antonio.
Gotcha.
Oh, Jaron, what you just said about the black bar on the right, make that much bigger, because it's however many Earth diameters, but move it away the distance that the sun is. Now you'd see the shadow as you're seeing it now. The further away you move it, the narrower that shadow will get, to the point that the shadow couldn't be any wider or any narrower than the size of the sphere that's casting that shadow. So
I can show you evidence. I mean, if you go outside right now, take a bottle cap, attach it to a coat hanger, and move it away up into the sky. And as you watch that shadow on the ground, the first thing that'll happen is it will stay exactly the same size as you go up, and then the outer edges of that shadow will become blurred, and the middle heavy shadow will get smaller.
Yes, but this is where you're taking into account all of the ambient light which bleeds in from the sides. You can see this.
Exactly.
That's exactly right.
But that's what we're saying saying about the atmosphere. That's why I totally am in agreement with that the atmosphere is what's causing the shadow or the shadow. But what I'm saying is this picture being shown as proof of anything, is wrong.
Okay.
It isn't. What people should. There's a way of doing this like visually. Because we can draw out a tiny little sun, a speck of a moon, and a speck of an earth, and draw straight lines from the sun and see whether we can have a crossover point. We can do it on a big piece of paper, and what we'll see is that between the distance of the sun and the moon and the proximity to the earth, which is right next to it, all things considered, you don't get this. You don't get this top-down view. This is why when they depict it, they always have the sun very close up so they can have those crossover beams, because this is part of their neuro-linguistic programming. People see that image, they then say, okay, yes, I see this image, I understand this crossing over, but the sun is much, much bigger and much further away, but this crossover must still happen. Say, wait a second, test it yourself. We can do it, we can model it. Then if you test it, Jerome, with a torch, and you set it up the correct distances, and a penny or something, a grain of rice, and put it the distance away from your wall, you see, like, no, it doesn't work. There's not enough proximity of the sun for it to cause the crossover. Right. So the penumbra that we have, that's definitely an atmospheric thing that they try to claim is a crossover of sunbeams. It's like, no, it isn't. It's not a crossover of sunbeams at all.
Right.
And when they start saying that, then which is it? Is it Eratosthenes' parallel shadow angles always, as a rule, to prove the sphere, or is it crossing over? I mean, they really, science needs to make its mind up on this, and there is a bit of a stalemate now, isn't there?
Yes.
Yeah, and let me, first of all, I guess apologize for even using this image, but because it does not match what I'm saying, and I'm not being dishonest about it. I'm simply saying that, again, its apparent size of the sun and moon being the same, and the dynamic that it lays down on the Earth is inconsistent with the heliocentric model. It does seem to work with the flat Earth model, and let me kind of introduce a little bit of a thought experiment here. So we're looking at this thing right here, and whether this is fake or not is really kind of irrelevant, because what we're looking at on this is an eclipse shadow that I guess you could say it's about 70 miles by 70 miles. So let's just say that would be the shadow in one particular spot at one moment in time, okay? Now, the Earth is 4 times the size of the moon, right? And so if it is the moon that is getting in the way here and actually causing this very small dot, the 70 by 70 shadow on the Earth, and there is no penumbra or anything like that, so whatever. And even Charles has said, he thought it's fake. I know it's fake. We know it's fake. But for the sake of argument, let's just say that this is accurate in some degrees in the fact that it's about 70 miles wide. Now, if we turn this model around and we swap the position of the Earth and the moon and put the Earth in the way in front of the moon. Now the Earth is 4 times larger, so it would kind of stand to reason then, instead of having a 70 mile by 70 mile spot, you would have a 280 by 280 mile spot on the moon, right? Because all things being equal, the distances are roughly the same, all this stuff, and yet for whatever reason, the shadow supposedly of the Earth is covering the entire 2,100 mile diameter of the Earth. And this is what I'm saying by this is completely inconsistent with the heliocentric model, and this is kind of the way I'm seeing it. And I may be wrong, and if I am, lay it on me.
No, I was thinking of the same thing, Bob, and I actually thought about including that in my video. And in fact, I intended to. It just slipped my mind because I had so many other points to make in the video. But yeah, I totally agree that, okay, if you hand them the tapering shadow of the moon, which fluctuates, some years it's been as little as 2 miles in diameter in terms of the totality, if it is the moon. And then like this year, it's over 70 miles in diameter. So that fluctuates. But yeah, okay, so we'll take one instance, maybe average all of them, whatever, and apply that to the alleged diameter of the Earth, which is approximately 8,000 miles, and use that same ratio of tapering shadow, then yeah, it really doesn't work out now, does it?
Hey Bob, I've placed in the link in the Skype chat, I've placed the video from the Himawari 8 of the eclipse. Now, I don't know how many globelings want to look at this and have their brains fried, because you've seen the size of the eclipse that's going to happen across the US. So look at that and then compare it with this.
Yeah, that's...
And for me, I'd make sure that my position is stated clearly that the flat Earth describes the eclipse perfectly for me.
Yes.
Perfect. And in fact, the shadow makes sense with the being close to the sun, all that. But what I'm saying is that I will always argue for the truth. So when people use the wrong drawing or the wrong scale or the wrong idea, I'm going to point it out every time. I'm not going to just sit there and say, well, they're arguing on behalf of the flat Earth, so I'm going to let them show incorrect models, because that's what I hate NASA for. Everything NASA shows us is the wrong scale, is just to get a point across. It's not really accurate. And so I see the same thing going on with if we're going to call them out for the eclipse, there's so many other things to call them out on. But I mean, the eclipse being one of them, I agree. Definitely the size of the shadow and other things like that. But I feel like we're going to the wrong arguments. I don't think, if somewhere says that the West Coast is supposed to see the eclipse and then the East Coast is supposed to see it 5.5 hours later, that's a big deal. That should be brought up. But I hear it being brought up, but I don't see any evidence of it. Just people are just saying that. And I have not seen that yet. So I mean, I'm just going to point this out because I think that there's so much wrong with it that we don't need to invent things wrong with it.
Yeah.
Well, I think that the whole, sorry, Antonio, I think that the whole thing with the light and shadow, and I'll pass the mic right to you, is that's what we see in reality. Okay, if you take any spherical objects and any large omnidirectional light source and start playing with light and shadow, you're going to see certain things. One thing that you're never, ever going to see in reality, unless you start getting into lenses and stuff, which we mentioned a little bit before the show, you're just simply not going to see tapering conical shadows away from spherical obstructions of light in reality. So again, we have to swallow a lot of just rubbish in order to coalesce with the heliocentric theory. I think that's the point.
What Jaron's saying, and I get it, and it's true. If you have a really wide light and you put it close to an object, that white light is going to blur the edges and give you only a very small shadow as long as you've brought it into focus with the surface that it's going to fall on. But when you take that same bright light and you move it away without moving the shadow casting object from the focal point, as you move that away, the blur of the shadow, so where it fades, gets wider and wider to the point that it gets to the size of the object. It depends how much you move the thing away. But if we look at this graphic, for goodness sakes, the shadow on this graphic is at least as big as Papua New Guinea. I mean, that is a ridiculously large shadow. Now, it's lucky for them that they're showing it over the South Indian Ocean or going on to the Pacific. If they showed that over America, it would be half of America at least. Now, if we take, Jaron, what you said about the time between the western coast and the eastern coast, one of the things that we all love doing is questioning what they tell us, what they give us. So I'm looking at this, I'm thinking, okay, I'm going to ignore for now Eastern Russia. I'm going to ignore Western Europe. I'm going to ignore that. 1 hour and 1 hour and 25 minutes over the US. That's what they say, something like that. Yeah.
It might be more actually. I think it's more like 2.5 or something.
Right. But this is the thing. If you look in various different astronomical places, they give you different results. It's like, okay, why are you not in accord? If you're all using the same model and the same math, you should all be in accord. There shouldn't be a few minutes here, a few minutes there, half an hour here, 40 minutes there difference. And there really are. So when you look at this, you go, well, how fast is the shadow traveling? How wide is the US from northwest to southeast?
Yeah, but here's the problem with that. And this is the problem with what people are doing. People are taking the speed of the shadow and thinking that they can put that across the entire Earth. And in their model, the Earth is a ball, meaning you're going to have the shadow move at a different speed. It's going to move incredibly fast, then it's going to move a little bit slower, then very slow, then a little bit faster, then extremely fast.
Yes.
Okay, well, that answers the question of why people have different numbers, because some people are just taking it as, how fast does the shadow move? It moves at this speed. Okay, this is how fast it goes across the entire United States, which is not correct.
No, but this is them. This is the astronomers with their numbers. Like, okay, you can understand an amateur or somebody just looking at it, not factoring in the shape of the shadow and how much more it covers in less time, which is why it's so much faster when it's on the edges of the globe and so on. It's like their details are giving you different readings.
And just, Jaron, this should settle you a little bit. Okay, so if you go to Wikipedia, the source of all truth in the world, the maximum eclipse totality duration is only 160 seconds. So that's a couple minutes, but the partial beginning UTC times is 15:46. 1606, and then it goes to total begin is 1648. Greatest eclipse is 1826. Total end is 20 and 1 minute. That's 20 hours and 1 minute. And the partial end is 2104. That's a total of about just over 5 hours. So that's what Wiki's claiming.
Correct. But somebody said earlier that it's 5 hours across the United States, which is incorrect. The eclipse goes all the way across from the ocean to ocean. It's not.
Oh, okay. So then we want to make sure we get this right, at least in terms of the actual numbers to expect, right? Yeah.
All right, that's all I'm saying is that just let's make sure we're arguing the right thing. Potter's Clay came out with a video, I think yesterday, a bunch of people commented on, where he said the shadow should move across the earth at 34 miles per hour or something like that. That is not a correct statement to say. It doesn't even make sense in any, how could it move at 34 miles per hour across the earth? I mean, it doesn't even make sense. But it's because he took the speed and then backed it down. If I took it half as far, if I took it a quarter as far, and he kept going and then said, put the moon right next to the earth and said, okay, it should only go 34 miles. Well, of course, because the speed of the moon would change no matter how far away it is from the earth. Meaning if it's doing one revolution per 27 earth revolutions, then the closer it is to the earth, the slower it must go. The further away from the earth, the faster it must go. We know how that works. You could just figure out the circumference, time over distance, that equals your speed. So if you put the moon next to the sun, it would fly through that little band of light at so fast you wouldn't even see it. And as you move it to where the moon is supposedly in their model, then it goes through at a certain speed. And if you moved it next to the earth, then it's going to go by the earth at 34 miles per hour. That is not okay to then make a video about that and say, so this means that the shadow should go across the earth at 34 miles per hour. That's the kind of thing where I'm just like, well, I just feel like there's so many things wrong to not make statements that they can easily just get rid of. That's just not correct. You can't move the moon closer to the earth and then say, okay, this is the speed that the shadow would go, because the moon in their model, again, it's not something I believe. I hate this more than anything about this whole thing is having to explain their model, because I think it's disgusting, but I think there's so much wrong with it that let's argue the wrong point.
Yeah, with the lunar eclipse, Bob just showed the lunar eclipse on the video. With the lunar eclipse, we have literally the opposite of what they explain. When people look at the lunar eclipse, the shadow that starts covering the moon is not penumbral, it's complete pitch black. And as it enters further and further into the moon, the shadow starts to become kind of transparent, translucent. And then as it wears its way out, it goes back to completely opaque black. Their theory says the opposite to that. It says first it's translucent, then jet black, then translucent. No, it's not that. It's the opposite, and it always has been. And there's tons of video. There are millions of people have seen this. But their model has to explain it this other way, and people just don't notice. And if you point it out to them, they'll say, oh no, what it is your eyes are adjusting, or your camera's adjusting, or like, no, what? Look with your eyes, just look, because we're talking about a lunar eclipse. You don't need freaking visors and light blocking instruments. Their own models are wrong. Bob, where you're showing the transit of the eclipse through the US, that image that you've got that's like from that one. Yeah. If we were to look at this and transpose the shadow that went over the ocean over Australia from the Himawari 8, most of the US would be being covered by the shadow at any time when it was falling, in totality.
But most of the US is covered by the shadow. I'll be in the shadow.
No, I mean, their Himawari doesn't have a point where it's black and the rest is blurred. It's got a huge big area that's black.
Nowhere's going to be black. I mean, if you're in the path of totality, it's still going to it's not going to get pitch black like it's nighttime.
Yes, it gets pitch black where you can see the stars.
Barely you'll see a couple stars. It's not even close to being the same as at night.
I don't know. I've never seen one. I've never seen one myself.
Look here, I'm in California and I'll see over 75% of the eclipse. So I mean, what I'm saying is that Himawari view, I just feel like, to me, that when not NASA, but science has had 500 years to perfect their little story. And there's enough wrong with it because it's a lie that we can pull out things that are lies. But on something like this, I don't think they're going to show a shadow on the Himawari that's just dead wrong. It's just that's kind of exposing themselves to, hey, just come pick on us. So to me, whenever I see math issues, when I go look at them, and I know Rob Skiba had the same thing happen with him. When we saw the moon cross in front of the earth, we both said, fake as could be, it's fake. Well, you know what? You can stick to that theory, because I still do. That looks like CGI to me. It's not a real depiction. However, to argue it as saying the moon's too big, the moon wouldn't move at this speed, that is incorrect. And even Mike Potomac will say this. When you go back and you do the modeling of it, it is correct. NASA is going to get their math, their numbers correct, because that's what they're good at. But they're going to, so when you see that Himawari shadow go across, the reason that shadow is so big is because the entire United States will be in a shadow, right? It'll all be in a shadow because a piece of the sun will be blocked by the moon. Now, I will never see totality, but I'll be in the shadow. And so that dark band that we saw, if you go back to that Himawari, Bob, if you go back to the Himawari, there's that dark band that's in the middle, or the dark shadow, is not going to be pitch black. It's not going to be like, you can see a couple stars, and I think they're only the ones that are really close. I've never seen it get pitch black. I don't know where it is. Anyway.
Yeah, I'm looking for it. Here it is. There we go.
If you look at it move across the whole thing, it is about the size of the United States. So you'll see here, picture the United States, being there, and then if you look at this whole shadow, and there'll be a dark middle. See that little darkest spot in the middle? All that's saying is that little dark spot is where the path of totality would be, and then the bigger shadow is where people will see partial eclipse. So I guess my only issue is I think that there's, like I said, enough wrong with it that I just don't think some of the things that we're pointing out are necessarily wrong with it. That there's enough wrong with it that we can pick on those rather than to just say things that I don't think stand up if we do any research on it.
Yeah, can I chime in, Jaron?
Please, Mike.
Yeah, what Jaron's saying is 100% correct. The totality of the shadow that they are showing is from a model to scale perspective. I modeled the same thing, and I have my picture down here I shared with everybody. That's what I get for a shadow that will be moving across the Earth. And I don't know what Potter's Clay is doing or why he's doing it. Their math does work out. Now, where their math does not work out is the type of shadow we will observe, because we will observe an angular shadow as opposed to a round, perfect spotlight type shadow.
Mm-hmm. If you, Bob, did you pull up Steve Torrance's video? I passed it in the Skype chat earlier. I've also just... Whoa, sorry, guys.
Whoa. Goal.
Okay. Geez, which one is it? Let's see. That's Mike's. I think this is it. This isn't it. No. This is the one he just sent me. I'm sorry. Was it early in that, Antonio?
I think it was like the first thing he sent you, if I'm not mistaken.
Oh, okay.
Or one of the first, because I believe he mentioned it right before we went live.
Oh, so way back up at the top.
Yeah.
Okay. All right, we got David. Oh, crap. I have... Antonio, can you just drop in the chat again? Because I'm sitting here looking at the chat, and in this particular group, it goes on and on and on from all the other shows that we've had. So I'm lost. I'm sorry.
It's okay. It will take me 2 minutes. Apologies with the sound. I've got these two browsers. One is Opera, and it started playing in the background. It took me forever to find it. Oh. I'll find Steve Torrance's. And the thing about Steve Torrance is he is meticulous, with his data. So I'll find it. I'll pass it to you. It's only a very short video.
Is it a recent video? Because I'm on his page right now.
Yeah.
The Great American Eclipse?
That's it.
All right, cool. There we go. All right, there it is playing, and I will slow it down and play it again. So let's drop that down to about half speed. Go ahead.
If we factor this, okay, between the moon and the Earth, there's no atmosphere that can narrow the shadow. It would only be from the point that the moon's shadow arrives at the Earth that refraction could start interacting with it to narrow it. And there isn't enough depth of field. There's not enough depth in that atmosphere to allow for that narrowing. So what he's done is basically he's taken the globe model, the moon at the distance, the sun at the distance, the Earth, the time, and this is what the result is. Now, this is very different to what is going to happen in the real world, but it closer matches what the Himawari were showing. Now, we look at it, and we know that globelings, and what you're saying, yeah, I totally agree. Globelings are going to look, and they're going to factor it. They're going to say, well, a lot of that must be penumbra. I'm going to ignore the fact that it's changing the color of the clouds completely to like that, but it gets darker and darker towards the center, and the center must be the totality. It's like, well, no, anywhere within the shadow of the United States, anywhere under the shadow would be in totality. That means the border of Canada and the border of New Mexico, those people would be seeing totality. Anybody under that circle, if Steve Torrance plays it, would be in totality. But that's not what the real world is going to present. The real world is going to present what looks like the effect of something interacting with a very close sun. sun.
And I totally agree with that statement. What you just said is correct. What I'm saying is that sometimes we're saying it in a wrong way. This is an excellent depiction because you're right. That even when I showed in my video, when I slowed down and showed the moon crossing the light path, well, that's just saying that there would be a shadow on the Earth, right? I wasn't, as I said, there's a problem with the size of the shadow.
Yeah,
right, okay.
Yeah, and I think this brings up a really excellent point. I mean, logically, this is how you would expect the eclipses to work on the heliocentric model, and the fact that we see such tiny, diminished shadows, and the light from the sun is supposedly converging and diverging from itself. I mean, at some point in space, it just doesn't make as much sense. And like you said, Antonio, you brought up a really good point, is that if the Earth was the size of a basketball, and we're assuming a spherical Earth, the atmosphere would be like, what, an eighth of an inch, a 16th of an inch or something off that basketball or less?
Yeah, minuscule.
Yeah, so it doesn't have the refracting capability as they would like it to have.
So this is why I keep mentioning the neurolinguistic programming. When they show the sun, their truncated version with the sun with its crossover beams causing penumbra, that image is now fixed in people's minds, and they carry that image with them. So when they experience the eclipse and they experience the penumbra, they can visualize that image. That's why it's there. That's, guys, you've seen Darren Brown. You've seen how he tricks people into agreeing to things that they have no intention to agreeing to. This is how they do it. We have to give it to them. They are geniuses at manipulation, and this is part they do it. Here's an image. This is what's happening now. The sun is very far away, but I'm not going to show you that. I'm going to let you keep that image, because if they show you the sun being very far away, they can't show this crossover beam. It's not going to work. It doesn't work. So they don't show it. They show the close-up version.
Right, and that makes perfect sense to me. And by the way, for those of you who do not know who Darren Brown is, he does a television show in the UK, and it was here in the United States for a while, called Mind Control with Darren Brown. And if you haven't ever seen any of his work, it's astounding. And a lot of the stuff he does, he actually kind of gives away the secret as to how it's done. And he actually a lot of times will actually give away that secret, and it will show some really amazing dynamics of the human mind. And of course, our controllers are experts in this. They are experts in not only individual psychological behavior, but group sociological behavior, to the entire population. They know how it works. This is why advertising is such a big industry, because it's all about the mind games, and this is we're being barraged by it daily. And so yeah, I agree with you, Antonio. Part of this is the programming. It's just like what Red's Rhetoric was doing earlier. They will put out that trig and do it on the moon and say, yep, here it is. Yep, there's our proof, no problem. But they conveniently omit doing it on the sun. And this is for a very specific reason. So I agree.
And for all intents and purposes, the experiment that Jaron proposed earlier is really good. Hold the penny right up to a wall in the sunlight. Or if you want, angle a board, whatever, so it's absolutely facing the sun, and hold the penny right next to the surface of the board. Now, that's definitely a sun that's millions of times wider than the penny, but it's not going to cause this. It's not going to cause any crossover, and that's the equivalent in terms of distances between.
Right.
Yeah. Backing up the wagon a little bit, you mentioned hypnotism. So many people, sheeple, regular, normal, normies, whatever, they believe in hypnotism, but they won't believe that the government or big mainstream media uses hypnotism in their programming. And of course, now there is a law that I think it's still in effect, where hypnotists are not allowed to reveal exactly how hypnotism is done on television. However, I think that recently there was a law passed that the military, the CIA, basically mainstream media, can use hypnotic programming on the public at large legally. And now my contention is I believe they've been doing it the whole time. Now it's just technically legal. So that's my 2 cents on that.
Yeah.
Hey, look at the video.
Yes, that's Chris's video. So Chris, this sounds like a perfect time to cue you in and to talk about this video that you and I talked about yesterday. And if you want me to start it or move it at any particular place, let me know. But why don't you kind of give us an overview of what we're seeing here?
Okay, this right here is just basically what everybody's been talking about, that I'm demonstrating where the shadow can't be any smaller than the object itself. If you want to go to to the part of the video where it kind of shows where I put the magnification in, and it brings up right there. So what I do here is I add in magnification. And when you do that, then the object or the shadow will be smaller than the object itself if you add in magnification.
Right. And this is precisely what Flat Earth Consequences did as well. And we'll even show you the university. I'll show after this gets done. I'll show you that video and show you the university depiction of what they had to do to be able to decrease the size of the shadow itself. And also, didn't it had an effect on the penumbra as well, right, Chris?
Yeah, and that's one of the points that I wanted to talk about is I redid the experiment this morning and to make sure that what I was saying was correct. And I tried to do it in my living room to get the penumbra to come out, and you can't get the penumbra to come out in this unless you're in a very dark room. It's got to be pitch black with the light over the object to come up with the penumbra.
But we're also using a flashlight here, which is a single point source of light, which the sun has never been claimed to be. And we know that it's not. Go look at the sun. It's not brighter in the middle than it is at the edges. The sun is completely the same brightness at all sides. And so if you're using a flashlight, then you're not going to get the same effects that they claim to get with the sun, because it's a completely different light, completely different size. You would have to move that non-point source of light far enough away that from the perspective of the ground that the golf ball was blocking that light, right? Here, if you look at, the flashlight is actually smaller than the ball. Even the points, the light's coming out of a hole of a flashlight smaller than the moon.
So it's beam divergence that we're seeing in the shadow being magnified, basically. It's like inverted beam divergence, essentially, right?
Yeah, I mean, and I'm not even, again, like I said, I'm not arguing that this is the case, that the eclipse, the way they say it, is working. I'm just saying that this experiment to me is a good experiment in that it's showing that you need the magnification to shrink the shadow. But then, if we're talking about the penumbra and why is there no penumbra seen? Well, because the penumbra is a result of a larger light being shined on a tiny item, and that would create the umbra. I mean, I don't know how to explain it, because if you grab something in your house right now and I have a lighter here, but if you hold a lighter to an item, you can get an umbra and a penumbra. Now, I have the video, the umbra penumbra conundrum, because they use both. This is the mathematicians saying, in some cases, Aristophanes, all the beams come parallel, and then in other stories, when they need it, they use the penumbra and the umbra. That's totally true.
Yeah,
and go ahead, Ant. Sorry,
I was just going to say, if you hold the light source, I have a drawing light, Jaron. There's a bulb. It's about the size of a volleyball, round. So I can hold this up to an object, like next to a wall, hold it quite close, and absolutely you get penumbra. But it has to be close to the object. If I leave it and move away, as I move away, the shadow becomes more and more distinct, and it ends up being the size of the thing that that's casting the shadow. When I bring it back up, then you get penumbra. The shadow gets smaller. Yeah, totally. But it's this model, the sun right up to the moon. And as far as I know, this isn't, the model that they believe in. And two things, this battle, this representation versus the real world, and it doesn't work. Say, okay, now move the sun and put it however far away to fit with that. And there's no way you can get the crossover. None.
Right. Entirely frustrating that they use nothing but fake models to show it. And what I'm trying to say is that we shouldn't do the same back. Yeah. We shouldn't just take a fake representation of what they're saying and say, okay, this is why it doesn't work, because then we've given them an easy out by saying, no, you're not representing what we believe in.
Yeah.
I think what Chris did was...
When they show that model of the Earth with the dome on top, and they show the sun going around 3,000 miles high, and they say, you'd be able to see it from everywhere on Earth. Well, they're right. They're right. That is, but we don't believe that. So the problem I have is when you show that, I just dismiss your video because you don't understand what I believe. So you're knocking down a straw man. I feel like we're just doing the same. When you show a model that isn't what they believe, you're building a straw man, building a proof around it that they're going to dismiss. Because as soon as you say something that they don't believe, like for instance, they believe the sun is not a single point source of light. Well, basically every light that we have is a single point source of light. Every light. So when people say, oh, well, we don't get this in my bedroom, I don't get with the same kind of shadow. Well, that's because you're looking at a light that is brighter in the middle than it is on the outside. It's a single point source of light, where the sun is a bazillion, according to them, single point sources of light. It's light everywhere, which we see, right? If we go outside and we can see that is true.
I don't think so. I disagree with that. I mean, if you think about it logically, if the sun was hitting the entire Earth at parallel angles, then the angular size of the sun should completely fill the sky at high noon, at least in my opinion. Although we see the sun as about the same angular size as the moon. And I think what Chris did was really nice, because I was sitting here worried, well, not worried, but just trying to make sense of the data where we do have these specific annular eclipses where the shadow of the moon is less than 2 miles in diameter. And so I think that a lot of that can be, at least in a flat Earth matrix, can be sort of modeled out the way you did using a magnifying lens or whatever, because, the atmosphere, I really do believe, behaves like that. But when you stretch this thing out to the geocentric levels, then the moon, like in this example that we're looking at here, the moon would have to be some 30 Earth diameter distances away, and the source light of the sun would have to be, I don't know, like on the other side of the state or whatever, right? And so we can't, we really can't model this out logically, at least not in their model.
Chris did an excellent job. I'm saying that was a great experiment to show the flat Earth model, right? But then somebody said something about, well, we don't see an umbra there, and I'm just saying, well, that's not what they believe. So it's a great model to show why it happens on a flat Earth, that we believe that the atmosphere is doing the refracting. It's acting as a lens. We believe all that. This is a great experiment for that, but this does not show the globe model in any way.
Can I chime in?
Sure, Mike. Go ahead.
Yeah, I did model this to scale, by the way, and get the same results NASA and the MRRI 8 get, because I come to find out the type of shadow they produced was the same type of shadow I produced, which is an incomplete shadow. It's not a real world shadow that we would observe. It's just something that modeling software would make, but it is to scale, and it is the correct distance and sizes, and it does produce the shadow, the small shadow that they'll claim. And so Jaron is 100% correct. We can't depict their model with a flashlight or anything we can model at home. We simply have to look at this to scale. Now, what you're showing here is what I did. This is very rough, probably not accurate, probably not the moon leaving the shadow. We're going to have a lot of P900s out that day, but it would absolutely have to be just a few hundred miles above Earth to leave the type of shadow that they're claiming. Now, that's the flat Earth side. That's not what they're saying.
And
go ahead.
Can I jump in here real quick?
Sure, Chris, go ahead.
And through that experiment, the one thing that I found out was, and again, it's something that I done at home, but the penumbra, to get the penumbra to come out, the only way to do that is get the light close to the blocking source. When you start pulling the light away from the object, you start losing the penumbra really quickly.
It gets to the point where it will match the size, and then it will just
of the umbra.
Yeah,
exactly. That's what I come up with in the few experiments that I've done.
And that in their model, that must be the result because of the distance of the source of light, the multi-point source of light, the object casting the shadow, and its proximity to the surface. It would have to be the size of that object. I mean, there's no, unless they bring in a factor like some strange refractive quality in the vacuum of space to create the effect that the lens is creating in your video, which, they keep changing things. Like now, the vacuum of space is not quite a vacuum. When did that change?
And they also, I don't know if anybody saw it, but they've already started backpedaling about how big the sun is now.
Yes.
Trying to answer some of these questions. It's the same thing they do all the time. They keep adjusting their models when people come up with good, valid questions on why it doesn't fit our reality.
So what are they saying is the new size of the sun?
They haven't committed to it yet. They're going to wait till after the eclipse is over, probably calculate the numbers, and then come up with their so-called different size of the sun.
Wow.
Yeah, may I chime in here? John has a good question. And John, their answer is we're going to examine the eclipse because if you look in there, modeling suggests the sun can be hundreds of miles larger. Well, modeling suggested to me, and tracking where they claim the photons are going, the sun cannot leave any shadow on the Earth, period. And here I put in the link for you guys. This is a real-world sun using not an artificial fake computer light like NASA and the MRRI did, which leave incomplete, inconsistent shadows that are not real shadows in their modeling of it. This is a real world shadow, real sun to size. It's not a computer light. And this sun model I made is scaled to distance and has a bazillion surfaces on a high poly model to leave enough photons shooting out across which my modeling software will interpret a shadow. However, there is no shadow. And I have the shadow supposedly over the United States. The sun is simply too small, too far away to our perspective to leave any type of shadow on the Earth. And if I understand photons correctly that give us light, then my understanding is the light more likely would not get any sunlight at all if I'm not getting any photons because they are so scattered at those angles from that distance.
Right. Yeah.
That makes sense.
You're basically talking about the lack of photons at the target. I've addressed this before, calling it, saying that the inverse square law prohibits this from happening, and that's kind of what you're saying in a little bit different terms, Mike. But I agree with you. And by the way, this what we're talking about, John, we actually covered this last week. I brought this up where the Daily Mail, now NASA's scientists are saying that the sun may be hundreds of miles bigger, which of course hundreds of miles is pretty small in comparison to an 865,000 mile diameter. But it's interesting that they're claiming this because obviously they're trying to redefine their model for whatever reason. And so the tale will be told apparently after the August 21st eclipse.
They try all kinds of things. When we were all discussing the boundary conditions of the upper atmosphere next to the zero pressure of space, they quickly hashed up a model where the radiation from the sun was bombarding down on those gases, creating the equivalent to some barrier. And they haven't carried on because even a halfway could say, well, what about in the night side of the Earth? Wouldn't it be wouldn't the radiation that's cascading onto the Earth also be rushing past the Earth? Shouldn't the Terminator have this bizarre situation where all the atmosphere is being driven away by that same magnetism? But they do this all the time. We've seen already that the curvature mathematics has had a little tweak, am I the only one that's seen this? It was just 8 inches per mile squared. Mm-hmm. Now it's 8 inches per mile squared, but you've got to bring in this extra element. And it's like, of course, they're going to fudge things because they're trying to say that the Emperor has got new clothes and they're wonderful.
Yeah. Well, and also, Antonio, one thing that I pointed out before as well, when you're dealing with the 8 inches per mile squared formula, if the Earth was truly an oblate spheroid or a little bit chubbier at the bottom, as Neil deGrasse Tyson says, giving it more of a pear shape, that would necessitate then that in the northern hemisphere, it would be required that it's actually a little bit more than 8 inches per mile squared. And then when you get down into that chubbiness, it would be maybe a little bit less. But for anything done in the northern hemisphere, they just screwed themselves on that statement.
And John made a really good point. John, I watched your the video or the hangout where you explained, when you get the pictorial representation of the curvature mathematics, and you've got the observer, you've got the target point, you've got the line of sight, you've got the distance of the horizon, and then the hidden distance. So when you're looking at a mountain, you have the mountain represented as the mountain size exaggerated. What they should do is start to incorporate angular resolution and say, look, mountain at this distance, angular resolution has diminished. At this other distance, angular resolution is a freaking tiny little dot at that distance.
Right. Yeah, it totally is. And like in order to really get the curvature formula right, because see, what we're seeing on flat Earth is just perspective and probably a little bit of atmospheric lensing to drop objects down apparently past the horizon. So that's what we see in reality. But when you get up a mile and a half, like 2016 July Pic de Fenestrellis thing I've done a couple videos on, it's the world record for land, long distance land photography. It's a 273 mile distant peak. However, that peak is 2.5 miles. You can see the entire mountain range, and it is obviously drastically magnified, the mountain range is. But in order to get the curvature formula right, we have to figure in perspective, which is apparent diminution in size due to distance, and that's what we see. Plus, you'd have to figure in the curvature of the Earth. Plus, you'd have to figure in refraction, which goes the opposite way. Refraction always brings light down. So all this is working against the globe, not for the globe at all.
Right, right. Let me throw in one other thing also, guys, that for your consideration. And, we've had a lot of people say, well, the 8 inches per mile squared doesn't work. And the reason is this, they say. And they say because, try it going beyond 1,000 miles. And of course, we've looked at this, and I actually have a graph of it here I could pull up here in a minute. But once you go past 1,000 miles and you compare it to the Sagitta calculations, you will find that there is quite a divergence that goes on from there. And by the time you get to 2,000 and 3,000 miles, it's pretty wildly off. Well, why is this? Well, the reason is because when you are using this exponent, function, the 8 inches per mile squared, basically that exponent just keeps on going in kind of a linear direction. And so if you were to actually plot that out, what you would see is that curve would go around once, but it would actually come back around inside of itself the second time around. And if you kept plotting it, just kept going for more and more distance, you'd find that what it would actually create would be a spiral, right? So again, Jaron, and we've talked about this before, in that it seems that, if you're going to do curvature calculations, there should be a constant there that represents the constant curvature of a circle. But when you're dealing with the exponential value of the inches per mile squared, ultimately when you plot it out, it turns into a flip and spiral. And so yes, it's good for up to 1,000 miles. In fact, it's very, very close to the Sagitta and even AutoCAD calculations. AutoCAD even falls off as well, but the Sagitta is pretty much right on the money. But if you keep going around in that circle, eventually it's going to plot out in a spiral. So yes, if you want to look at it in that strict confinement, then absolutely it's wrong. But it's absolutely right, and an incredibly good rule of thumb, if you will, incredibly accurate rule of thumb for anything up to 1,000 miles, which is really all we need for our purposes anyway. Because let's face it, any measurement we do, we'd be lucky to get 100 miles, maybe a couple hundred miles, whatever, as far as using visuals. So for our purposes, 8 inches per mile squared is absolutely, positively satisfactory. IMHO.
Yeah, agreed.
Mike has shared in the Skype chat what the moon would actually look like to the human eye at a distance of 238,000 miles. It's in the chat, in the Skype chat.
Oh, okay. Let me pull that up.
It's basically the angular resolution.
This.
It's below that.
Below it. Oh, crap. There's another one. I'm sorry. I apologize. Let me allow that. And
yeah, you showed my photon impossibility there.
All right. Oh, there you go. There you go. Is that it?
Now yeah, that's it. Now, that's high resolution. You can zoom in on that and see the markings on the moon. I didn't cheat. This photo is extremely large. I didn't cheat. You can actually zoom in. But we see these, what people refer to, I'll just call them craters for simplicity's sake. We see these with our own eye. We can actually see Tycho, according to NASA, being 54 miles in diameter with the naked eye. And here's the thing with their model, they show us two narratives, which whatever suits them, and then people have to realize this. But we could not possibly see any distinct markings on the moon at those distances. The sun also will appear as a small dot in the sky. However, we do have the atmospheric lensing of the sun that we would need to account for. So I just wanted to share that.
Okay, very good. Okay, and then this is the thing that I wanted to share. This was actually created by Kirk Curious Life, and here we have a comparison of using the Sagitta, the 8 inches per mile squared, and AutoCAD. And as we can see, they're all pretty close in agreement. Here we're going down 1, 2, 3, 5, 10 miles, etc. We get up to 100 miles. They're all, right there with each other. And up to 1,000 miles, 125.62, 0.26. Okay, the AutoCAD is straying a bit there. But now we're going to see the 8 inches per mile squared really start to go into a problem here. The 8 inches per mile squared, when we look at it at 1/4, it comes up as 48.93. We know that's correct. The Sagitta would be closer to the 39.89 or whatever. Basically, this is close, within 65 miles. So that's looking at them and breaking them down individually. And like I said, Kirk did this a long time ago, and I just think it's a really good representation. But up to 100 miles, up to even 1,000 miles, it's quite good. And it really doesn't really diverge all that much until you start getting into, over 2,500 miles. So
yeah, there was a Globehead recently did a video, and they said that they've come up with a new curvature formula, and it is a sinusoidal curvature formula because, of course, once you get to the quarter of the distance from the observer, then the Earth starts curving back underneath and towards the observer. But of course, when Robotham came up with this formula, and it does work with AutoCAD, so it's good enough for me. When are we going to see further than 500 miles, really? You know what I mean? So when you get into 1,000 miles, I think that you're right. It's sort of irrelevant, but it is nice to have that accuracy and know that the curvature formula does work with pretty damn good accuracy up to 200, 300, 400 miles.
Right. But of course, the whole reason for all of this hoopla about the curvature and everybody saying, oh, no, it's wrong, it's wrong, it's wrong. Well, the reason they're trying to even subdue that even further is because there is no curvature. Therefore, they're trying to mathematically weasel their way out of any curvature even being able to be detected and, ultimately show that the Earth would have to be 3 times its size probably, to be able to show 8 inches per mile. So again, they're just trying to hamper the efforts. And again, when you take away that curvature, then all you're left with is observable phenomenon, right? Empirical evidence, just like what the Red and TJ or the Red and Jaron discussion that TJ covered. You take out their hypothetical, their theoretical curvature, which nobody has ever seen or measured. That throws a big wrench in the works, and that is exactly why they're trying to do this.
And what's even crazier is that we all go by this chart, granted, but on a flat Earth, it doesn't matter what the size of the equator is. It has nothing to do
exactly
with right. So, I mean, really, that's why I think it's important that we really look into the idea that they've lied about the equator distance, because if the equator is only 21,000 miles, and this is why I've always wondered, well, how did they get observations to match kind of what we see as far as these distances, right? Always seems like it's really close, or we have to add a little refraction to, push this item up a little bit, but it looks pretty close. Well, it could be because they just reverse engineered your eyesight. How much distance does it take for something to reduce to the size that you can't see it? Then they took that and said, well, what would that be on a ball? They came up with 24901, said 24901 is the equator.
Yeah, exactly. And that's the whole thing. They engineered this construct from the very beginning. And it makes me wonder, because it's so funny how everything centers around this whole 2/3. There's this 666 comes up in so many places, not to mention the Bible, whatever, however you want to look at it. But even in our geometry, it is absolutely replete everywhere where this number keeps coming up over and over and over again. And that can't be a coincidence, right? At least not in my mind. So, I think, they've had a long time to figure this out. And, for all we know, we're basing it on calculations for just a section. Maybe if we were on a big ball or something, it's just a little section or something where we're not even able to see it. And maybe it's so much bigger. And that's the reason they are doing is to hide all this other land. Of course, obviously, I think the more likely explanation is that it is a flat plane. And that's the reason why the South and North Pole are both off limits, because there's some very interesting anomalies that we simply are not allowed to be known about, because that will blow their entire model and their lie right out of the water. So, we have other means.
You've just said it, their lie. We have to remember this. We're looking at the world and we're trying to find ways of unpicking their model and demonstrating the reality of the world as honestly as we can. They have a model that tells them it's perfectly fine as long as your lie is good enough.
Yes.
Because we know there are people out there who are knowingly lying about climate change, about the shape of the earth, about astronomy, about resources, about all kinds of stuff. And to them, it's justified to lie. Let's not forget, this is a mirage. No, that's a lie. That was not a mirage. And they put that out there, and we've all seen it. All the globelings have seen it, and half of them believe it. They believe that that's a mirage, if not all of them.
Yeah.
And earlier you said that they can't see it, or they can't accommodate, they can't take on. And this is the thing, they literally can't. Like with Darren Brown, okay? They cannot, they've been programmed, they've had filters installed, and they literally cannot see the lack of curvature. They can't see it. They can see curvature. They fool themselves. The horizon, the lake over there, that's the horizon. And on a misty day, now the world is really small. All of these things, they brush them aside. One day the horizon is the limit of your sight with the water. Another day, that water's closer because of the atmospheric conditions. And for that, they say, the horizon is there because of the atmosphere. And we say the horizon is there all of the time because of the atmosphere and your perspective. And it feels like we're arguing with Dougal from Father Ted, trying to explain to him the difference.
And the reason why is because when you look at like Wolfie, somebody like Wolfie 6020, who's said numerous times that they could not have tricked him with math, that it's he knows that the Earth is a ball and he could not have been tricked. Well, when you have that attitude, then you're going into every experiment or every observation, and now you're in a race with yourself, meaning that you have to prove to yourself that you couldn't have been lied to about this. Whereas the people who are flat earthers have already accepted the fact that, yeah, a group of people could get together and make up a lie that I would believe. And once you realize that, then you can start picking apart their arguments, and then the lies start popping out everywhere. But I'm never having to protect myself from saying, I'm so smart I couldn't be fooled. The reason for that is if I find out that the Earth was a ball somehow, some way, well, it's not my fault. I would say, well, look at these guys. This is the way they taught the ball was ridiculous. So I don't feel bad. I don't feel stupid because I thought that it wasn't a ball, because they've never taught the ball in a way that makes it anywhere near understandable. So the difference is you got people like Neil deGrasse, all these guys who promote the globe, they're up against themselves because they've already admitted, or they've already said, there's no way they could be fooled about this. There's no way a lie could be that big. There's no way that a conspiracy this big could exist. Well, they're going to do everything in their power to prove that, because the alternative is saying, oh shit, I am dumb enough that they fooled me. Oh shit, they could fool me with math. Oh no, this is a big lie. That's the difference between flat earthers and ball earthers.
I have a ball earth friend who literally said that he can concept, when I tried to explain to him the difference between physical impossibility and logical impossibility, I said, like, for instance, it's logically impossible to conceive of a cube that's red and blue all over. And he said, oh, I can conceive of that. I said, no, you can't. He said, yes, I can. I just can't explain it. I said, no, you can't. It's not conceivable. You cannot conceive of one thing that is two mutually exclusive things at the same time. You cannot have a cube that's red and blue all over. And he said he can, and he's a globeling. So whenever we're talking about the globe, it's like, dude, you think you can magically conceive of something that's inconceivable. So whatever your globe is letting you conceive, it's not true. Its parameters are broken, and they can't conceptualize it. That's what it is. Not only that they might be fooled, but that it really is still by that lakeside on the picnic. It really is. It's so simple. They can't grasp it.
I would say that it's a purple cube.
If I may, what Antonio's saying, our observations do not match their numbers or model. Jaron, I was talking with you about the claim that the moon turns upside down. Now, you said that's explained a different way. I have on Quarry here where they've used Polaris that orientated appears to be maybe 45 degrees. They claim that we will see the moon differently from Australia. Now, they're also claiming, and I have a link, that Australia from the northern side will see the Big Dipper upside down. And I just wanted to know what you thought about that, and the fact that cannot possibly be true, because I put two photos of the moon from the North and South Pole of an Earth model to scale. It doesn't orientate any differently because it's only 1.96 degrees going up or down from North to South Pole according to the distance of the moon. So maybe we can get a kind of an idea, if what they claim is true, that the moon would have to be extremely close if it does orientate differently, and or if the Big Dipper does flip upside down for Australia.
That's excellent. No, that's great. I would love to see that modeling, because what I was saying is that the moon, if you were to draw north at the top of the moon and south at the bottom, and then you went to the south, the moon doesn't turn upside down, because north is still north and south is still south. It just so happens that from your technical perspective, it would be the opposite way. You'd see it the opposite way, but it's still north is north, south is south. The best way to describe this would be, let's picture we're on a ball first, and then you've got a train cart, and you're laying on the train. Okay, so you're laying your back on the train, you're about to go for a ride from the south to the north. As you started to go, wherever the moon was, let's say it's north is at its top and south is at its bottom, as you took that train to the northern hemisphere, the north of the moon is still in the north and the south is still in the south. It didn't turn upside down. At one point you would have been kind of looking back over your head behind you on the train, but it never changed. It doesn't flip, right? I mean, it's your perspective. But what you're saying is true. I also believe that the moon has to be close. It's kind of like when we do the drawing of, draw a circle, put it on your ceiling in your bedroom, put an A and a B. If you walk from one side of the room to the other, the moon flips upside down. That's a close perspective, right? Whereas if you're talking about, you modeled it out at 230,000 miles and it wouldn't show it being upside down?
Right, and I put both pictures up there, extreme North Pole model and South Pole. Bob could share those. And I put the link to where Stellaris claims that the moon would orientate differently if you were in Australia from the UK, which is simply impossible because you can only move a total of 1.96 degrees compared to perspective and distance of the moon on the Earth. And so your moon's not going to orientate any differently. However, people claim that from their observation, the moon does change differently. And from their observation, they see the Big Dipper that we see in North America upside down from the northern end of Australia, which is also impossible.
And that would include any other stars as well, right? Not just the Big Dipper, wouldn't it?
It would include every star. In fact, on the heliocentric model, when I modeled it out, we would only see half the stars one part of the year and the other half the other part of the year. And
right.
there's no getting around that.
Right. Hey, Mike, would you like to screen share any of this? Or because I've got these two up, I don't know if these are the right ones, but I can certainly present you. Whoops, you there, Mike?
Oh, you hung up.
I just dropped.
No, I didn't hang up. I'm here, Bob.
Okay.
I hit mute so you guys could talk. If you want to screen share, that's fine.
Yeah, I'll present you. Go ahead and hit your screen share, and I will stop sharing myself, and we will bring you up.
And just to clarify, an easier way to kind of describe what I'm saying is if you put a circle up on your ceiling and you marked north, south, east, west per the bedroom that you're in, and you walked from one side of the room to the other, that north is still north. So that's where when I was saying it doesn't flip as in, well, now the north side of the moon that you see north is south, and the south side of the moon, no, the moon doesn't change. Does that make sense? Does that make more sense? If I looked from this side of the room and I looked at the N on the moon, it would be towards me. If I walked to the other side of the room, the N would be on the other side of me, but north is still north.
Right. What Jaron says makes absolute sense. And I don't think maybe they're claiming the moon turns upside down on Australia. Does anybody see my screen here?
Yeah, we see it.
Yeah.
What I'm saying is they're modeling software. Now, this is Stellaris, I guess, and they show an orientation from the UK to what Australia will see.
I don't think his screen's coming on the live stream. I think you still need to share your screen.
It is.
Mike.
It is.
Is it?
It is. Yeah.
Okay, sorry.
And if you can see this part here, what they're claiming on their model will flip over this way here. Also, the Big Dipper, they claim that we will see an upside down Big Dipper if we are in Australia, which is also impossible. And what we'll see is the same Big Dipper, and we see the same star patterns 365 days a year. According to the heliocentric model, we would not see stars, the same stars on this side as we would on this side, simply because we have daylight on this side. And so what that tells me in trying to model this, I can't model it on the given flat Earth dome. It just doesn't work. The only way that matches our observation flat Earth wise is the sun and moon extremely close to us and a star field that is laid out flat above us, moving in some type of way. That's
what I have. I have the stars and the moon and the sun being no higher than 75 miles. And the sky works as a flat, it's an optical illusion, meaning that the further you look, the more atmosphere you're looking through, so you get the bent view of the things that are setting, stars that are setting, but they're not. It's just a straight plate across the top of your head. And yeah, what you're saying is exactly what I've tried to say before about the moon, is that yes, from the flat plane, if you walked from one side to the other, north is still north, south is still south on your moon. But I think on the globe, that if you were to be at the top of the globe and you looked in the north, the moon was north at the top and south at the bottom. Well, if you walked to the South Pole, then the moon would flip, meaning that then your south end would be to the north and your north end to the south. But that doesn't happen.
I shared a link it's the bottom thing in the Skype chat, but this is just something that I found really interesting. I put the clip in a few videos, and basically it's just refraction and what can happen to light just simply by passing through different media. And like if you put an empty glass of water in front of two arrows and then start filling that glass with water, the arrows will start turning around in the opposite direction. And so if the atmosphere or the atmos plane is a low-lying fluid, and it's not equidistant, so it's not exactly a plane perhaps, then I can see that sort of thing occurring to the stars in different hemisphere, perhaps.
That is so
just
cool.
A thought.
That is so cool.
Pretty sweet, huh?
I love that demonstration. Yep, that's awesome.
Awesome.
Okay, so all right. Well, Chris, you still had, or you may still have a couple things, or were there a couple other things that you wanted to cover before we kind of move on to whatever's next?
No, I think that covers it.
Okay, cool. And Mike, did you have anything else that you wanted to share with everybody before we go on to the next thing? Because I don't have a whole lot left, just a couple little minor things to share. But so we're kind of at 3 hours now and getting ready to wrap up. But we certainly have time for a few more minutes if you have anything else you want to throw at us.
The only thing I would share is cover how the Himawari and the Epic Discover made their animations, why their animations and shadows are called shadows. And that would I'm going to run a video on that. I just wanted the audience and the people in chat to realize that I'm finding the same things you guys are finding. What Jern talked about, we're looking at an extremely close sun and moon, and we are looking at a lot of refractive and reflective atmospheric conditions that change over time due to humidity, whatever, smog, that skew our observations. But the sun and moon, folks, is just right above you. I seriously doubt we're even going to reach the couple 100-mile marks on those from what we're finding out. That's all I wanted to add.
Okay.
Yeah. Okay. I tend to agree. I mean, just on intuition alone, it really doesn't make a whole lot of sense that the sun and moon are very distant or large. Although I think the atmosphere or the atmosphere plane itself does magnify greatly in terms of their apparent angular size.
Absolutely. And in fact, I don't think that we can see stars from above the atmosphere. I'm not even sure you can see the sun. So, that might be just an activity of the atmosphere itself that's rendering those to us.
Yeah. I guarantee you that Eric Dollard and Peter Lindemann would tell you that, no, you cannot see the stars or the sun from above the atmosphere. And they're pretty adamant about it. And these guys are a couple of PhDs. So, of course, that doesn't...
What height are you talking?
I'm sorry?
Do you know what height do you think they're talking when they say above the atmosphere? I know there's stratosphere messes. Do you know where they're talking about that you would lose it?
They're not saying specifically, but when you listen to Peter Lindemann or Eric Dollard, they're simply saying that it would not be visible from space. And in fact, we've also heard this backed up. Assuming the astronauts had any credibility either, or maybe they have been in some sort of low Earth orbit, whatever. But they describe that they really can't see anything from up there either, save they look through the optics, right?
Well, it depends on who you ask, though. Of course, some astronauts say it's filled with lights, including the zodiacal lights, and other astronauts say there are no stars in space. So it's just a deep black, like Neil Armstrong claimed, right?
Well, yeah, and also Chris Hadfield until he changes his story, and also Hairspray Lady, same thing, So obviously you can't get anything that even you can take to the bank at all from the lying astronauts because they're full of it. They've never been up there. The best I would say that they would ever have been, assuming they've ever even done that, is been in low Earth orbit, and whatever that means. But if there's any sincerity at all to it, it would seem to me that they are talking that they simply can't see those lights. And also there's another guy, Tom, I can't remember his name, but I covered him, I don't know, quite a few months ago, but he's kind of buddy-buddy with all these people in the NASA science and engineering departments, and he's come out on video and he's quite openly discussed, what conversations he's had with who, and basically it's funny because one division of NASA will tell him that they can see this stuff, and then the other division, the one that I would consider would be the more credible one, if you can even say that, tells him that no, we've never been able to get any pictures of any lights out in space. So
even from the ISS, they'll make the excuse when you say why is there no stars? Because when there's something bright in the view like the Earth, you can't see the stars, or when there's something bright like the sun or the moon. But we'll see pitch black all the time. Half the time of the ISS view is just pitch black. So what is the big bright item that's blocking the stars in that case?
Right, camera aperture there. Well, it's because of the camera aperture. It's set perfectly for one thing for daytime on the Earth, but it's like almost any camera has an automatic aperture. That's so absurd that NASA in their billions in their budget that they can't have anything like that, nor have they ever even bothered to send up anything with an aperture setting perfectly for that. And yet, whenever they do the post-processing of the ISS footage, that's when they come out with these wonderful, you can see all the city lights, you can see the lightning strikes individually happening, and people look at that and believe that crap is real. And
we should crowdsource and buy them a P900 or something with an automatic focus.
Like you can
what Bob said's correct. Even the Epic Discover, they do this on purpose. The Epic Discover has a listed camera of 4 megapixels.
Yeah.
And that's so they can get around, post-process whatever they want and claim they didn't see whatever they were supposed to see. That's what's listed on that satellite 1 million miles out, and it's just totally crazy.
Look what they've convinced people of. They've convinced people that it's impressive that here's a 4K spacewalk, and it'll be 16 seconds or 22 seconds, whatever it was. But now from that point on, any rational thinking person should think to themselves, well, then every spacewalk going forward should be in 4K. But they'll go back to 360p tomorrow and show us another spacewalk, and people will just eat it up. Like, what's wrong with the camera that gave us 4K? It worked in that. What is their possible excuse for only being able to show 22 seconds of a spacewalk?
Well, with all the discrepancy, sorry, I'll be real quick. With all the discrepancy, like you mentioned with the stars, sometimes, we never see them in the live ISS feed. I think, part of what they're showing us may actually be real footage, and I'm not saying they're in low Earth orbit, unless you consider very high altitude flight low Earth orbit. And so I believe that the military does have some secret technology that's capable of super high altitude, long distance flight. Maybe even, since you've got such low drag up there, they maybe even have some high buoyancy devices up there, as crazy as that sounds. But perhaps some of what they're showing us is true, and you can't see the stars from that high. But that's giving them a lot of credit, maybe.
No, I think you're right, and I think I'm in the same boat as you. Is that otherwise, why not fake some of the stuff that they don't fake, right? Why keep showing the black sky with no stars? Well, I think that's because they really can't see them from where they're at. Where I draw the line is they're not getting in rocket and flying to whatever craft they're floating around it.
Right, absolutely not. Yeah, that's a big hoax. But with that big hoax, I think comes some real data, although even the real stuff is questionable. I mean, it could just as easily be CGI, right?
Yeah, and Mike Helmick's shown that they don't even need to be there. But I think there's so many things that we haven't looked into that it could be the case. That just that SFC6, which is the heavy gas that I don't know if you've seen videos. I'm sure they get like a fish tank and you can sit things on top of it. Well, what would happen if you pump that into some sort of craft? Could you get people to float? We don't know. The crazy thing about that is it makes your voice extremely low. But if you notice, every single video that we've ever seen from space, they use that microphone. At the bottom of that microphone is that box, which could easily be some sort of voice modulator, so that if they're speaking in a high voice, it's converting their voice back to normal.
Huh.
There's also magnetism. You've seen the frog floating in over a powerful magnet. Have you guys seen this footage?
Mm-hmm.
Yeah. There's I don't know if I'll be able to find it. So the float there's a locust or a grasshopper and a frog and a flower, various different things at different times, just levitating over a magnet inside a tube. The guy who's explaining what's happening says outright, there is no practical reason we can't do this with a human right now.
If you had strong enough magnets, huh?
So let me spend a couple of minutes trying to find the video.
Okay.
And it's not even a new video.
Okay.
I don't know if you've ever seen before. I've seen a video where they have this ring magnet in like the second story of a building, and they drop a big metal pipe through it, and it looks crazy because they drop it and it takes forever for the pipe to fall to the ground because it's going through this ring magnet that's totally holding up this huge heavy pipe. You ever seen that?
No, I haven't.
Oh, are you talking about the ring magnet? I was thinking that was a vacuum.
Oh,
never mind.
Cylinder magnet.
I've got it, guys.
Okay.
It's the Associated Press. Associated Press. I've just linked it in the chat here, Bob. And it bears listening to. It's only short, but the guy explains. He says there's no practical reason we can't do this now with humans.
Okay, whoops. Hang on a second. And we actually want to play this really quick.
Yeah, why not?
All right, cool. Hang on just a second. Let me back it up. And here we go. Let's hope the audio gets a little better.
I'll pretend to be a British narrator.
Yeah, because that's turned all the way up. We can hardly hear it.
As you can see, the frogs. Yeah. What is that, a newt?
Yes.
Oh, wow, there you go.
Yeah.
That's weird because that's something that Tiger Dan actually postulated about astronauts. They could be using something similar to this. a while back.
The audio does get better towards the end.
Well, the problem with this is one, to simulate weightlessness like this, you would have no control over your axis orientation, so it wouldn't work. How they do it, though, is Jet Propulsion Labs has signed a contract with the Microsoft HoloLens technology. They run 3 video layers across. This allows the astronauts to manipulate objects in weightlessness, also hold the same object in real time with them on their video layer. The technology is pretty amazing. But I have tracked, and that's what Jet Propulsion Labs is using in connection with Telemetrics, which has a contract with Johnson Space Center. This idea of floating humans by magnets sounds like a great idea, but they simply would not be able to control the axis rotation of the thing that they were floating, and hence break the illusion.
Yeah, and not only that, it would have one hell of an effect on you physiologically, I would think.
Well, if you listen to the very end of the video where you've got the guy in the suit talking, he's explaining that it's completely doable now with humans.
Well, yeah. But I think I tend to agree with what Mike is saying, because honestly, with the level of CGI technology that we have, why would you ever want to even mess around with something like this? And again, that would also leave a lot more room for errors or I guess problems, whereas the CGI would be more of a controlled, even though there are problems with it, it would be more of a controlled methodology, I would think.
The CGI really does break down sometimes, where you'll see examples of like a microphone passing through someone's hand, or like a fruit instantly appearing in the air, and then there's no cut at all, and the astronaut grabs the fruit or the teddy bear or whatever it is. And so, it looks like they're using VR or virtual reality and multi-layers to pull that off. But, we've been seeing this sort of thing from NASA since, I think, before CGI was able to pull this sort of thing off. And, if scientists are finding out this stuff with magnetism today, well, what could scientists with NASA's budget have found out in the 70s to trick us, right? And really, the sky's the limit, is my opinion.
Yeah, Mike, do you think that they are then in a parabolic flight at all times?
No, I think they're on the ground somewhere. Before 2012, they did have to fake it with the zero-G plane. This is why we have the cuts we had, or they had to make a post-production video where they could do the effects post-process. And I get a lot of those videos sent to me from Globe Earthers saying, see, that's not fake. Well, yeah, because anybody can make a movie. To pull off the live feeds, though, they are using the HoloLens and telemetrics technologies, which seems to work out fine, except as what John mentioned, and as we all know, the glitches and the microphone going through the hand. That's simply the software not interpreting where their hand is. Also, Peggy has a bad habit of putting her hand outside of that zone, and she keeps getting her hand elongated and her fingers cut off. So I'm surprised Peggy's still working with them.
Yeah, she's terrible. Right. But I think that also I've seen so many times where their center of balance is thrown off, that they then start almost laying down sideways. And that, to me, means that in those particular cases, they're either in a parabolic flight or in a floating some sort of environment, because you would never have that happen if you were just using wires. Plus, they also look like they have pressure on them a lot. Either they're upside down or they're having magnet or some sort of gas being pumped in that's causing them to feel that their eyes get kind of bulgy and they get kind of red, and that those kind of things wouldn't happen if you were just hanging on wires, unless you're upside down.
Yeah, and let's also not hang on, Antonio, I'll hand it right over to you, but let's also not overlook the obvious, guys, and that is that, levitation has been a magician's trick for a long, long time, and it's performed routinely. It's performed live in Vegas, all over the place. You can go and see it done. We don't know how that's done, but we know that they're doing it, and are also not doing it in front of a CGI or anything like that. So there are obviously other technologies out there that, can be very well concealed, because otherwise they wouldn't be able to do tricks like that as a street magician, right? So go ahead, Antonio.
Yeah. That's what I was going to say. David Copperfield on stage, floating, flying, getting into a glass cage, having a glass door placed over it, floating inside this glass cage back and forth.
Live.
And they have, live in front of a live audience, and they have the whole range. So they can use that. They can use the magnetism if they so choose, or the CGI, or a whole range of tricks. I watched Gravity, the film with Sandra Bullock and George Clooney. It's awesome. It's amazing. It's brilliant. alien. But we know that it wasn't, they're not actually in space. But, it wouldn't take much for them to say, no, actually, look, we made this documentary and this happened in space. And some Globelings would believe it if it wasn't that it was famous Hollywood stars.
All of them would believe it.
Yeah.
But I think the other thing to notice is when they do something wrong and we think we caught them, I always think they did it on purpose. So, for instance, the recent video, they had the guy go by with the cables and it looked like he's on wires.
He was totally on wires.
Well, here's the thing. To me, they did that on purpose. There's no way that somebody on wires is told to go by during the telecast. So when they do that on purpose, the reason is so that we all immediately jump on the they're on wires thing. That's what I think. And I think this is just what they've done for years is it pushes out. Now everyone's focused on the wires. And then when they can show something that is easily shown to not be wires, then that's their way of disproving us.
Yes.
So I always look at things from that perspective.
Yep. Jaron, let me share something with you really quick. As I've said many times before, I've always been kind of fascinated specifically with a magician by the name of Chris Angel. And so much so that I bought all of his DVDs and I would never miss Mind Freak or anything like that. And so I got this one DVD that exposed, basically he was supposedly showing how he did a lot of these tricks, right? And one of them in particular I found was really interesting, and that was, how he appeared to be levitating up above, this box. And the secret that was revealed and the way that it was shown, basically shown that there was a cutout in his pants and he basically stepped up without anybody being able to see it. And, that's how he appeared to levitate. However, when you looked at that and you looked at the real trick, all the angles and everything were completely different. So it was very clear that what he showed as the reveal for the trick was not really the reveal for the trick. But, obviously there was something much more high tech going on, or demonic, or however you want to look at it. But again, even when they say they're revealing these tricks, the solutions they're giving you are not actually what's happening. And I agree with you in their misleading.
Yeah, they love to get people to believe one way, and that's what's lasted so long. I think that the Bart Cybral thing, I've said that many times, that there's no way you accidentally send somebody who says, hey, I'm doing an investigation on the moon landings, can I get some videotapes? You don't accidentally send that person the tape that exposes the whole thing, but you do accidentally send that to them when you want them to put something out that you're okay with going out. It was okay for them to put out something that showed that they were using a cutout over the window to show the Earth, because if they knew people weren't going to believe in the moon landing, so now you give them this, now everybody banks on that, but it re-solidifies the Earth orbit. Right. And that's the trick. Then everybody who watches that, who doesn't believe in the moon landings, still believes in Earth orbit. So I think that whenever I see them make mistakes, I tend to look at them and say, okay, what is their, what reason could they have had for making this mistake? Why would you show a guy, he even looks at the camera. He's going by, looks at the camera as he's got the wires on, like they know that we're going to grab a hold of that and say, okay, they're using wires. So that's the way I look at all the things. And then when I see things that they don't do, like don't put a camera on the moon, don't put a camera on the ISS that's 24/7, don't show us, those are the things we need to push on, because if they could, they would.
Right.
Hey, real quick, because I know we're pressed for time, but just an interesting story, since I mentioned the world record long distance landscape photography, I actually emailed the guy that took that photo, the 273-mile photo of the distant mountains before sunrise, and he emailed me back. I had originally emailed him to ask permission to use that image in my book that I'm working on, and he said, sure. And he said, what's your book about? And I figured, okay, this guy's got to at least know something about flat Earth, so I made a very sort of quick, concise case for the Earth not having curvature. It showed him some examples, did a nice long email back to him. So he emailed me back, and the guy, Brett, has no clue about flat Earth at all. The guy who took the world record long distance landscape photography record in 2016 is totally never heard of flat Earth before. So I emailed him back again, sent him some video links, and I don't think I've heard back from him again. But I had postulated on earlier episodes that he must be a flat Earther, but I was incorrect, and hopefully that will change.
Very interesting.
Can I?
Sure, Antonio.
Can I address something?
Yeah,
Can I address something about intelligent people who look at the flat Earth and don't become activists, pro-flat Earth, don't make videos, don't make comments, even though they look at it and they go, yeah, could be, and carry on with their life. I know people like this, okay? Like in the real world, people who look and say, okay, I still have to earn my money, I still have to do this. They tend to be very practical people. Like one of them's a civil engineer, the other one's a joiner. They're very practical people. They're aware of the conspiracies, and they just put it off like, yeah, doesn't surprise me. They've been lying all along, and they just put it off to the side, and they carry on with their day. Just because they do that, it doesn't mean they're bad people. It takes a certain temperament to do what we're doing, you know? If the temperament that says, right, well, I'm not going to just carry on and let it continue. I'm going to do something about it if I can. But they're not bad people. This is what I'm trying to say. Right. People who do that, who have attitude, that we can see it as, well, they're kind of helping the lie by not exposing it. They're not pushing it either, you know?
That's true. And we've all been there.
What I've found, too, that's sort of similar to this is there's a lot of people that just didn't really care much about science. Like, I was way into science and NASA and everything, so to me this was a huge shock. But, you know, to other people who maybe were less interested in science, it's not that big of a deal, right? Maybe. I don't know. I'm only me.
Yeah, and then there are the people who have a big problem with liars and with cunning and manipulation and abuse, which is ultimately what this is about. You know, this is about abuse. It's about abusing the whole of the human consciousness, and that's what drives us. So they have different motivational drivers, and, you know, we can't expect everybody to be like us. Yep. You know, that's all I'm trying to say.
Yep, absolutely true. Okay, so moving on to a couple other things really quick, and then we'll get out of here. I wanted to point this out last week and ran out of time. And almost ran out of time this week, but I still want to point it out. Our friend and former Globebuster, Kirk, Curious Life, who was Curious Life of a Flat Earther, last week came out with a video called 1 Horizon plus 0 Curvature equals Flat Earth. And basically, what it's about, it says a quick video to introduce the idea that the horizon is actually a result of the point of inflection in our vision. Now, this is another one of those things, guys, that is definitely a factor in our model. We certainly cannot take ourselves or our vision or our sensing mechanisms out of the equation that when we're looking at this. Yes, we've got to look at physical measurements of the Earth. As far as curvature, we've got to look at horizon, atmospheric lensing factors. But unless we take ourselves into the equation as well, then we're kind of incomplete. So basically, what Kirk is going over in this is he's talking about angular resolution of the eye and the certain specific angles that even somebody with perfect, more or less perfect 20/20 vision has to contend with. And we are all subject to these specifications of a human being. So this is something that, it needs to be taken into consideration whenever you're considering your perspective on anything, because the perspective starts right in your eyes, right? So I would definitely recommend that people go over and check this out. Kirk does fantastic work. Always been a big fan of his. And he's got a very practical approach to the way that, he spells this out. And this is his second such video on angular resolution that has been absolutely superior. So I definitely wanted to get a plug out there on this and, tell people go over and check it out. And I will put it in the show notes afterwards. All right. And then Anthony Riley wanted me to kind of mention this for people to check out the Flat Earth Eclipse Challenge for Ballers and Flats. Now, admittedly, I have not seen this, so I don't even know what he's selling, more or less, but I do know that he's a good guy and a flat earther, so I'm going to kind of take him on face value that this probably got some good merit to it. So I'm going to check it out myself, and I would ask that everybody else also go check it out, because he seems to think that he's onto something here, and that's great. Maybe he is, and if so, kudos to you and more power to you. I think that's great. And lastly, Dorje Daka came out with a video this week that absolutely just cracked me up. And basically what it is, it's a tour guide, and that is, giving a tour through the NASA, I guess, Space Museum or whatever. But he says, I cannot believe people actually think it's possible for there to be thrust in a vacuum. I agree, Dorje. NASA lies have the masses brainwashed. Here we can see the homeless tweaker shelter in a museum and an example of people who have lost the ability to question. And what's funny about this is here we have this guy, this genius, which is, he's worried about his badge, so I don't know if he thinks he's an employee of SpaceX or whatever. But a couple questions are asked about how it is possible to maneuver around in a vacuum? And the answer that this guy gives is absolutely classic. I'm gonna play the answer just for laughs, but let me back up here just a second. I'll let you hear the question and then the answer, and we'll go from here.
Tell me.
The cone down there, as the gases flow out.
Do you mind if you kind of need something to push off for that? Maybe you don't know this, but how exactly does propulsion work in a vacuum? You know, you kind of need something to push off for that opposite reaction. How does like combustion and propulsion work in a vacuum of nothingness, essentially?
My understanding is it does not take much at all. Go ahead. You have the answer.
Been building solid rockets for a while.
Oh, there we go. He's got someone who can tell me.
The cone down there, as the gases flow out.
Do you mind if I record?
No.
Okay, that'd be great for this video I'm doing.
As long as the gas comes out that cone, and as it does, it expands. Because it's been, if you look inside the cone, there's a very small area of diameter. So when the gas flows through there, it accelerates. And that acceleration, then as it expands, is what pushes on the cone.
Interesting.
Wow. So when you drop an apple, the apple moving away from your hand propels your hand upwards in an opposite direction.
Yeah, something like that. But I mean, this guy's convinced that, because it's sped up, once it's pushed out, of course, he fails to mention that, it's bleeding off into an infinite vacuum or, something that's going to instantaneously neutralize any thrust that would be generated had there been some atmosphere there. But I mean, he's perfectly satisfied with his answer, thinking that, the Venturi in the rocket itself, just because it speeds it up. And what he's describing is akin to putting your thumb over the end of a hose, right? And making the water accelerate and speed up. And he says, well, then that's going to cause, opposite thrust. The problem is the reason that happens, of course, in an atmosphere is because there's something to work against. There is not in space. So, I mean, I couldn't believe some of the answers that are coming, not only from the tour guide himself, but this guy who, like I said, he says, oh, as long as I don't have my badge on, I don't know who he thinks he works for. But just a little bit of comedy relief. Super good video by Dorje Daka. Haven't seen it, check it out. And that, sirs, is all I have. So I'm going to go around and give everybody the opportunity to say what they have coming up or anything like that. And I guess, Mike, we can start with you. You have anything else you want to leave us with?
Well, Bob, it was just a connection with the ocular vision or the circular vision that we see a flat plane. I left you a photo in the bottom that is taken from a flat plane, but the way the light comes in around the camera lens or our eyes would actually curved surface. And we see a lot of that. Rob Skiba's balloon, his 7.2 millimeter lens, showed this effect at 1,000 feet and at 100,000 feet. So I just wanted to add that. One more thing I'll add for the people in chat, if you're kind of figuring out, well, why can't we see the stars above the clouds? We have a theory. It's based on electromagnetic. I am going to say I personally do not know if it's a quantum field theory or unified electromagnetic field theory. We're just guessing. I think the electromagnetic field theory has a lot of evidence that can be supported through demonstrable observations. And so what we believe, and it's just a theory, is that the sun, moon, and stars are moving above Earth much like a rainbow would. They are circular and they go to one end of the Earth to the other. Now, I know that supports a model you guys do not subscribe to, but we're looking at the polar magnetics of a positive and a negative to explain the opposite counter rotations of the stars that NASA shows us ourselves. And if this is true, that the stars are much like the rainbow, then we would not observe them from a certain height once we get above that rainbow up above us. And that's all I wanted to add. That's what we're looking at. And I'm not trying to bring up models or cross models here, that we're just trying to make sense out of it.
Very interesting, Mike. Okay. Well, and we're interested in stuff, especially me, because, if it has anything to do with an electromagnetic model, I'm all over it, right? So I'm definitely open-minded to that stuff, and I'd love to hear the rest of it at some point, so I hope you come out with a video on it, or maybe I could even get on a discussion with it, on it with you at some point. That'd be great. And then also the picture that you're showing here, I assume this is the effect you're talking about, kind of like the barrel distortion, where Sly Sparkane went off and basically claimed as a result of Rob Skiba's video, which is actually Victor Brewer's video, and the barrel distortion in it, that this proves the Earth is a curve. Is this type of phenomena you're talking about?
Right, but my lens has no barrel distortion. It's just simply the way the light comes in at the end end of the lens, because cameras and humans both see circular. They don't see in boxes.
Yes. Okay. Beautiful. All right. Very good. Okay. And so then we will move on to you, Antonio. Do you have anything you want to cover real quick before we cut out of here?
Yes, real quick and completely selfish. I offered to send out a lot of hand-drawn maps. I'm going away on holiday on Tuesday, so tomorrow I will send out as many as I can. Any that I don't send out tomorrow, I will send when I return in September. That's really it. And then people can do with them what they like. So apologies if you've asked for one and I don't get around to it. It took me 4 hours the other night just to write down the addresses that people have emailed. So it's a pretty labor-intensive thing.
Oh,
that's all.
Yeah, and we're going to have to send you our address as well, because I'd like to have a copy of that. And Cami has made some remarks, and obviously there's some differences, that's something we want to talk about at some point as well. So
well, even if people use it really just to reorient them as they choose, the ratios are correct, so people can move them around. One area between Thailand and Australia, so that kind of Australasian area with Singapore and Indonesia. There's somebody brought my attention to something called the Wallace line, which is right there between Thailand heading off towards Antarctica. There's a region where the apparent proximity in terms of globe degrees says that there should be lots of cross-pollination and lots of fauna that is shared between these islands, but strangely there isn't. There are very distinct pulls, or extremes between this point west. There's a completely different variety of birds, insects, marsupials, a whole range of things that's in that region. I think this region is a region where they've cropped the ocean. So on the globe, it looks like they're very, very close, but in the real world, they're more distant. And this explains the lack of birds, the lack of other wildlife between them. It's just the Wallace line. This is called the Wallace line. So please, anybody interested, look into it. And that's it. Thanks, Bob, for having me. Jaron, John, everybody else, thank you very much. It's been a pleasure. I will see you all. I'm going to have to bail. I will see you all in September. Good luck with the eclipse and enjoy everything else.
All right, sounds good, Antonio. Have a great trip.
Yeah, cheers, we'll make the eclipse happen.
Bye.
All right. Cool. All right. And that brings us...
Also, if I will, Jaron, it's been a pleasure talking to you for the first time. And John, glad to meet you guys. Follow all your stuff. Bob, I know I've talked to you several times before. And just keep it flat.
Absolutely. You too, Mike. And thanks for joining us today. It's been great. Okay, so now we will move over to you, Chris. Chris, so you have, like I said, you've got all kinds of experiments that you do all the time. And, this is one thing that I do want to go over with you, Chris. Whew, almost forgot about it. All right, so Chris and I and Cami are basically going to Nebraska. And, what the heck? What's the name of the town we're going to, Chris?
Alliance, Nebraska.
Okay, we're going to Alliance, Nebraska, which is dead nuts in the middle of the eclipse, okay? So basically what we're going to do is Chris has made some reservations since hotels are impossibly hard to get, and of course traffic is going to be like national emergency status if you listen to the news and all that stuff. So we're basically going to go up there over the weekend and go to this place. It's a campsite, okay? And it costs, like $50 a pop for the campsite, but at this campsite we're going to, not only is it right in the middle of the eclipse, but it has like concessions and all kinds of, kind of home conveniences, even though you will still wind up pitching a tent there. So it'll be cool. We'll be able to do a little camp in there. Chris will have all of his his solar telescope set up. I'll be there with my P900 and my solar filter that Chris was nice enough to give me, which is awesome. So we'll be taking pictures there. And also at some point around there, either from there or right around there, we're going to be launching our balloon. So that's one thing I did want to cover. Now, Chris, you have some extra tickets for this, and do you want to kind of tell people about it? And maybe, we bought them because, we certainly wanted to get our spot and everything, but he did get one for Jaron, and I think you got, 7 or 8 of them, something like that. So we have a few extras left over. So, Chris, you want to talk about that real quick?
Sure. Before I do, how many have you promised out of the tickets so far?
I haven't promised any. However, I know Cami is talking to people about it, so I'm honestly not sure. But I guess if there are any left over, maybe you would be the person, or to see on that, and to join us possibly up at that campsite. So, but they're your tickets, so I'll let you set the terms.
Okay, yeah. I guess anybody that's interested, either get a hold of me or Bob and Cammy. And the name of the place is called Toad Stock in Alliance, Nebraska. And they may still have tickets available for this. And I looked for weeks for motels and campsites, and it was the only one that I could find in the path of totality that was within 3.5, 4-hour drive from Denver here. So I guess if you're interested, get a hold of me, Bob, or Cammy, and we'll go from there.
Yeah, especially if you're interested in helping us launch the balloon, because we are going to be launching the balloon. Oh, and by the way, on that, what we finally settled on, guys, boy, I'll tell you, buying the cameras for this solar eclipse, wow, has it been easier than trying to figure out the stars one. But ultimately, what we have is 2 GoPro 5s. I bought one, Chris has one, and then the other one is a GoPro Plus. Is that correct, Chris?
Yeah, a Hero Plus.
A Hero Plus. Okay, yeah. We've got Hero 5s and the Hero Plus, and we're going to be putting some solar film on one of the cameras, and we're not sure exactly how we're going to configure the other 2. However, I do want to have one of them absolutely raw, because I think that'll probably be helpful in trying to capture any black bodies that are up there. But so we've got all that set up. We've got the cameras. The only thing that we have yet to buy is the helium. So, and that'll be something obviously we're going to be doing here very, very soon. So we can take that up there with us. But we can definitely use the help in launching the balloon, potentially recovering it and whatever. And so, again, get in touch with either Chris or myself, bob@jeranism.com. And in any event, we'll be, telling, well, we just did. We told where we're going, and when we're going to be there. And so you can either make plans accordingly. You can check the place, see if they have any tickets, or if not, then possibly you could get Chris to part with a couple of his, or whatever. But it'll be a party. It'll be fun, and it's this has got to be the most interesting thing that has happened to the country in a long, long time. So it's going to be one heck of an event any way you look at it. And if assuming they don't spray the crap out of the sky, hopefully we'll get some really good footage from the ground. Otherwise, the balloon launch is going to be the thing. And you know what I'm hoping, Chris, is that they don't pull this nonsense, since NASA is going to be launching their jets and following the eclipse, that they put any type of ban on a balloon. So, because they don't want any of their jets running into it. That would be, something that I would almost expect. But I think it's going to be a lot of fun.
Yes, and I know BMLSB69 has contacted me, and he's interested to meet up with us and help out.
Yeah, yes. And also, I just got an email from Dwayne Kellum. And Dwayne Kellum, like Victor Brewer is launching a balloon, and it's going to be a gimbaled balloon, I believe. And Dwayne Kellum sent me an email this morning, and his balloon he's setting up on gimbals also. So that's going to be awesome that we'll have these gimbaled balloons and be able to target the sun directly. Now, here's Dwayne's problem. Apparently, he ordered a couple of balloons, and I don't know why he ordered them from overseas, but in coming through customs, they opened it with a razor knife, and it sliced the stupid balloon in two. And now, apparently, the balloon suppliers are getting real flaky about supplying balloons to him. So I fired back with some suggestions, possibly about using high altitude science, which is who we got our balloon from. And we also still have that huge balloon that you sent to us, Jaron. So I don't know if that would help him or not, but if so, I'd be more than happy to send it to him. But so Dwayne's kind of sweating bullets as to whether or not he's going to have an actual balloon to attach his payload to. So that's kind of where we're at with that, which is unfortunate. So as he keeps us up to date on that, and I'm not sure, I think he is going probably more to the southeast to catch his eclipse footage, but that may change. So that's what's going on with him. So we're going to have gimbaled launches from Victor Brewer, from Dwayne Kellum, and we're just doing the normal old launch with 3 GoPro cameras, at least one outfitted with a solar filter. And that's where we're at with that. So anything else, Chris, that you want to mention before we go?
No, just other than to say thanks for everybody's kind comments on my videos and for all the new subscribers.
Beautiful.
And thank you guys. And thank you guys for having me on today.
Chris, go ahead and give everybody your channel because you've done some awesome experiments and your channel's great and you should have a ton more subs. So please go sub Chris, but go ahead and tell them your channel.
My channel's basically my name. Bob's putting it up there on the screen.
Yes, I am.
CHRISVANMATRE.
Okay, there you go. Chris Van Maitre, and there is his channel. And I will also be putting that in the link. It's also in last week's show, or no, I'm sorry, not last week's show. What am I saying? It's in other shows, but it'll definitely be in today's show link. And yeah, by all means, subscribe to him because honestly, well, at least you got up to 500 now, but 500 is still a crime, you know, for you to only have that few when you have done such exceptional experiments, Chris. So by all means, do give him a sub. So thank you very much, Chris, for joining us today. And then we will move over to John. John, you got anything new and exciting on the horizon?
Yeah, all the time, but I would just say to the live viewers, thanks guys for hanging out. Love you all. Thanks to the guests. We had a great panel, Chris, Antonio, Michael, and then of course Bob and Jaron. You guys are great. Love you guys. And to those of y'all out there who aren't already subscribed to the Morgile channel, don't forget to subscribe. I've got some new stuff out pretty recently. And if you were subscribed in the past, that doesn't necessarily mean you're still subscribed. So double check, ring the bell, and that's all you got to do. That's it for me, guys.
All right, fair enough. And last but not least, Jaron, what do you got on the horizon?
I just want to thank everybody for watching, and I appreciate all you guys so much. And I did want to point out that if my channel disappears in the next couple days, that I will be back and hope you all resubscribe. I did get a strike from the David Seaman video, and just so people know what's going on with that, Nathan Stoltman had 35,000 subs or something like that, and then did some research on David Seaman and made a video about him, and it was well researched and contained only facts and references to articles. So I thought it was a good video. And at an event that Nathan was at in Washington, D.C., David Seaman basically pointed him out and told people there that he was protecting pedophiles or something. And so soon after, Nathan basically lost his channel because then David Seaman did a live stream where he told people to go over to Nathan's channel and flag all his videos. So when Nathan lost his channel, I was pretty pissed, mostly because I think of YouTube as a independent media. And I went back and watched his video again just to make sure that, you know, Nathan didn't say anything that I thought was wrong. And no, he reported facts. And so since I was so pissed, I just said, well, I'm going to make a video. And this was just me. It wasn't Nathan, had nothing to do with it. He didn't even know I did it until I put it out. But I said, I'm going to make a video that just contains facts, just the evidence, not going to tell anybody to do anything, like go over to his channel. In fact, I even said in my video, if you want to subscribe to David, here's his link. And I put out the video, and then I got hit with a copyright strike. And then the next day, which was yesterday, I guess, David went live and told all his viewers which is 150,000 subs, to go to my channel and flag all my videos and flag my channel. So I'm just preparing for what I think is going to happen, and just want people to you know, see what happened in that particular case, which is somebody being called out for doing things incorrectly and then getting people's channels shut down. And that's the absolute worst thing that YouTube can be used for. You've got people doing real research and showing evidence, and then people who are being called out somehow have an ability to get people's channels removed. So just
what he's doing is sounds pretty libel and slander to me. I mean, that's using power of you know, he has a captive audience and basically telling them to attack your channel. And God, when did the world come to this? I'm telling you, man. Yeah,
it's pretty gross. And you know, what can you do? I was making a stand and thought that I did it the right way by saying, okay, I understand somebody, you know, you're lying about somebody, or you're okay, then that person should have their channel removed. But I absolutely had no fear, and I still don't, that I'm not going to back down. You know, because he did that to Nathan should not be a sign to other people like, oh, don't ever bring up something that David Seaman did because you'll get your channel shut down. So I was making a stand, and it looks like I may get burned for it. And if I do, so be it. I'll come back and go again. But I certainly will never back down just because some people have the ability to do what he's doing.
Yeah. Wow.
Yeah. I made a video on him and he didn't do anything. So maybe I just keep that to myself.
Yeah, I would. I
destroyed his ass, Flat Earth. Honestly, maybe that's why he didn't touch it.
Yeah. Could be. That's really bad. Well, you'll have the support of the community. You can be assured of that, Jaron, for sure. But wow, that's really that's low. That's low rent. So okay.
Well, hopefully, see, I don't have any reason to think that YouTube would act a different way than they did already. But if they do, well, maybe it's not going to do anything. But I just wanted people to don't think I went away or anything. It's just going to take a while to get a channel back up and get going. So if you don't see me, keep looking.
Yeah, I hope you got everything backed up. I know you do, but just make sure. Yeah. Okay, cool. All right, guys. Well, I guess that will be it then. We will end it on that note, and we'll be back next week. There is just to let you guys know, the Sunday before the eclipse, I don't think I will be able to host the show. Now, if we do a show, maybe you can host it, Jaron, and I may be able to chime in remotely, but obviously we're going to be well on our way up to Nebraska, so just kind of, put that on your calendars, that I doubt I'll be able to actually host the show then because of where we're going to be going. So, but other than that, it's the 21st, so it'd be which is a Monday, so that would be the show date of the 20th in 2 weeks.
Okay.
So just
I can take care of that.
Give you a heads up. And I don't see any reason why I can't join remotely from the road, but I certainly cannot run the show, that's for sure. So, all right, guys. All right, we will call it a day. Thanks for joining us. We appreciate you all, and we will see you next week, hopefully, with another great show. So until then, be good to each other. Don't lie to each other. Open your mind. There's truth inside. Peace out, everybody.
Peace.
Peace.